I love me some lo-fi DMCA beats. I love me some lo-fi DMCA free beats, I should say. Not DMCA beats, that would be a big problem. Right, guys? What's up? Happy Friday. Nice to see everybody. Nami BJ, Occupy Paul Street. You got right Joy-Con at the top. I almost said left Joy-Con. That'd be the wrong Joy-Con, right? We got me. We got Migru. Migru's name is so dark, it's always hard for me to read it in the chat. But what's up, everybody? It's good to see you all. Yeah, you know, it's Friday. Friday, things happen today. One exciting thing, you guys. I don't know. Is it normal to show off your vaccine thing? Check it out. This is shot 2, baby. I'm gonna be sick, maybe, and then I'm gonna be healthy, right? So I hope you guys are all getting your vaccines out there. I hear it's a personal decision, but actually, I think everybody should just get their vaccine. So I don't know about that. I think it's more of a community decision. But hey, hope you're getting one if you can. Hope you can get one if you want. And yeah, I don't know. I went to a CVS to get mine, a random CVS in Manhattan. It was kind of pretty normal. Kind of walk in. They're like, "Are you here for the vaccine?" You say yes. You're just waiting in a CVS next to like the, you know, the vitamins. So that's pretty cool. He or she types same words. What? Okay, that's a better color, Migru. I like that. I can actually read that. An attractive little red-orange kind of thing. Less decision here and more can you even? Yeah, I feel that. Hope that comes your way soon, Nami. Pratik, how's it going? Good to see you, my friend. It's probably already late, 10 p.m. where you are, but I hope you had a good day and you're having a good night. Personal decision part is whether you want to be a burden to society or not. Well said, right, Joy-Con? Juicy Bit, how's it going? Less than RJ Plinskin? RP Litskin? I butchered your name. Sorry about that. I like to say less than Junior Pliskin. That's what I'm thinking of you as. Hydron, what's going on? You take the color of my t-shirt. Nice, that's a good one too. Yeah, so what's up, everybody? How was your week? I feel like for me, it was kind of a long week. It was kind of, a lot of things happened this week. Pretty tiring. MD Layer, thank you so much. Holy crap. 1 year LFG. That is intense. I can't believe that I've been even doing this for a year. That's actually kind of crazy, but thank you so much for your support. Really appreciate it. And yeah, I guess I owe people like a 1 year retrospective. I feel like I owe myself a 1 year retrospective. How's it been going? What have I learned? What are my plans? I don't know. I think it's been so easy to keep this up for a year because it's so fun. So I don't know. That's just the way things go, I guess, here on Twitch. Undefined behavior, what is up? GopherCon. I would very much like to go to GopherCon this year. I'm not sure if, yeah, anyway, I'll definitely try to make it to GopherCon this year. It should be really exciting. 1 year means 24-hour stream. Yeah, I don't know about that. Technically fall into group 2, which is quite helpful. Requested an appointment. That's awesome. Great to hear, Nami. You're vaccinated. You'll be there. Yeah, I was just showing off my little my Band-Aid on stream. So I'll be vaccinated fully by the time that GopherCon comes as well. So 24-hour would be murder. Yeah. Yeah, you know, I don't know how people do that kind of thing. I think it seems probably impossible if you're having to do something that requires thinking. I feel like with the gaming maybe it's a little bit more possible, a little bit more tolerable potentially, but I don't really know. Probably not coding. Yeah. You made deploy of a dev application on new work. It was hard. Are you saying it was hard or it could have been harder? I'm not sure what you're saying, Migru. But yeah, so I don't know. I guess yeah. So what happened? What happened last week? One cool thing that happened is that we managed to merge the JSON vectorized PR. So that's exciting. If you guys were around last time, you remember we worked on adding this built-in JSON data type to vectorize. So that's about making sure that you can use the faster vectorized code to do operations that use JSON. So this was a pretty cool project. I feel like it went really well. Big shout out to Yahor, if he's on the stream yet, for being so quick with the review and some with some fixes as well, and some help there. But this is such a cool thing, and I think it'll make a pretty big difference for people. So I'm pretty excited about it. Gamozo does 16+ hour coding streams, but he's an alien. Yeah, that guy, I've popped into Gamozo's stream a couple of times. He's got quite the setup, dude. He's got like 6 monitors. He's like got all the crazy camera angles, and he's doing, God even knows what he's doing, like Rust stuff, like kernel stuff, fuzzing stuff, right? It seems pretty awesome. I got a raid from Gamozo, which was awesome. I really appreciated that. And yeah, it seems like he's all about the fuzzing lifestyle, right? I think that fuzzing stuff is so cool. We do some fuzzing in Cockroach. But probably we could be doing more. Yeah, so anyway. Right, I thought I was showing this on screen, but I actually wasn't. This is what we were looking at last time, right? This built-in JSON stuff got merged. Super exciting. But for today, right, the question is what we're going to do next. I think I've got a couple of options. I think it might be more of like an exploratory thing. I'll talk about it in a second. How do you choose which database to use? You got to think about your use case. You got to think about the scale. You got to think about your schema. There's all sorts of things to think about. But yeah, it's. I think you have to learn by experience. Maybe that's part of it, right? You got to make a choice and then live with the consequences. That certainly happened to me in my first job. We used a lot of Cassandra, and I did this big project building this graph database thing on top of Cassandra. Terrible choice. Should not have used Cassandra for that. That made no sense. But I learned my lesson. You know, I was lucky enough that I was working at a place where they let me fail. So I got to learn quite a lot about it. Migru, oh my gosh, don't need to apologize. I was just trying to understand what you were saying is all. You don't speak English every day, just reading and watching videos. I think your English is great for just reading and watching videos, but no need to apologize at all. If I say something like that, it probably just means I didn't quite get your meaning. AZZPR and Akioli, thank you guys for the follows. Yeah, so anyway, basically, right, for today, what are we going to do? So you know how Cockroach does SQL? We've talked about it a lot. It does this, it's a SQL database. We know that. It's a distributed SQL database. We also know that, right? And we know that when we run queries on a distributed SQL database, it can actually distribute more than just the data. It can also distribute the processing, right? That's what we call dist SQL. Let me show you a quick example here. So we're gonna run Cockroach demo nodes equals 3. So we love to use this Cockroach demo thing. It spins up an in-memory cluster. You can put multiple nodes in it if you want. So we're gonna go to our default DB. Let's make a table. We'll just give it 2 columns. And we'll do our favorite thing, which is to insert some fake data into the table. So we'll maybe put 10,000 rows. We'll do 100,000 rows. Why not? Let's go crazy, guys. Into the table. And so we can do, a little select count star. For May, we've got our 10,000, 100,000 rows. And so the question is, right, how does the database decide how to process this query? Right now, you can see that the table is split up into one range. And again, in Cockroach, data is split up into ranges. Ranges are these chunks of contiguous data, and they're the unit of replication in Cockroach. So each range is replicated separately with a separate wrap group. So right now, since the data is small and since there's no load on it, there's just a single range for it. So I'm going to artificially split it. Alter table A, split at values. I can say maybe we'll do a 30,000, do a 60,000, do a 90,000. We'll just pointlessly keep it relatively even, I guess. Although it doesn't really matter. And so now if I show ranges again, you'll see that there are 4 ranges, and they're all replicated to all 3 of the replicas, and they're all got leaseholder number 1. And I guess that's probably just because, well, there's no reason for them to move around, have different leaseholders. They've started out on leaseholder 1, so I guess they don't need to move for any reason until later. We can ask them to move though with this scatter thing. So if I say alter table A scatter, I think what this does is randomly assign a leaseholder for each of the ranges. And so I got, a different distribution. It's kind of unlucky. I didn't get any 2s. So I'm going to do it again until I get one from all the nodes. Wow, I'm getting so unlucky. There we go. Okay, so I've got 3, 3, 1, 2. It seems like pretty good. We've got some data on each of the tables, and not just data, right, but leaseholders. Still haven't told you about the task, Nami. I'm holding it back. I'm withholding it. We're going to be talking about just networking stuff. Talking about looking at some of the details and the edges in between network, between nodes in the query graph. Something that we haven't really done a lot of on stream. Something that I want to learn a little bit more about. It's part of the code that's kind of been around for a long time. It's kind of static. Hasn't changed too much. I think there's some improvements we could make to that. There's some things that we could learn about. So I'm just giving a little bit of background about what distributed SQL does and stuff like that. And we'll dive into this task pretty soon though. So if I were to now say select count star from A, and if in fact I'm going to say explain this SQL, select count star from A, this is going to give me a link that I can theoretically click that shows us how this query is getting run across the cluster. And I think this is such a cool thing. I'm drinking tea today, but what this is a diagram of where all of the different processing parts on each of the nodes lives on, right? Null bitmap. This is the second 1-year subscription I've gotten today, but thank you so much. It's crazy. Really appreciate your support. We should be doing a 1-year celebration stream of some sort, right? Like, come on, what am I doing? You gotta rake in all those, celebration emotes or something. But thanks again for, 1 year, man. Really appreciate it. So, yeah, what this picture shows what the graph of the different parts of the query plan is, right? You can see that on node 2, which owns the data between 0 and 30,000. It's going to read the data between 0 and 30,000, count the data up, and send just the result of that count down to this main node. And this is pretty sweet because, of course, it means that we don't have to send all of that data, all of the data between 0 and 30,000. It can be skipped. It can be aggregated together and ignored. Don't have to send it over the network. It's very cheap to send just a single number after the end of that scan. And of course, if you imagine what the database would have to do without the SQL, it would have to read all the rows from the gateway, and it would have to be streaming all of those rows from each of the nodes that the gateway is not, and that's going to be very expensive, so very, very slow. OIDC server. Oh yeah, Ori Hydra. The Ori Hydra people have been looking at Cockroach. They've run into a couple of problems that we need to solve. Schema scalability is something that they really need for their application that we don't do such a good job on yet. They really need to have what by schema I really mean like the schema object, the thing that lives in between a database and a table. They really want to have tens of thousands of those things, and that's just, we haven't really quite managed to make that use case work particularly well in Cockroach just yet. But I'm excited to have Hydra succeed on Cockroach. It should be really good. Like the coloring. I'm not sure how new this is, but anyway, so this stuff is cool, but it kind of begs the question, how do you send the rows over the network, right? What is this? How is it working, right? So I mentioned, this is doing 0 through 30,000. This is doing 60,000 through the end. And this guy happens to have the middle the middle data between 30,000 and 60,000. And it's also the node that's serving the query itself, but that doesn't really matter. It's kind of symmetrical. It's kind of nice. So, if I run this thing, well, it doesn't give us very much interesting stuff. You can run explain analyze on it. This is kind of new, actually. I don't know if people have seen this exactly, but we used to not really support textual explain analyze, which we now support. So you can just run explain analyze on something and it'll come back and give you kind of like an annotated explain plan like they do in Postgres or in other databases. I think it's pretty convenient. You used to have to kind of do it through that picture, and now we can do it on the terminal, which is pretty nice. You see all sorts of interesting data. Rows read from KV, 100,000. That was 3.2 megabytes of data read. 26 milliseconds spent in KV. So that's like the time spent kind of reading data, quote unquote, from disk. Of course, it's a little bit more complicated than that in reality, but that's okay. That's why we say in KV and not from disk, because it's a little bit murky. Used 70 kilobytes. It sent a tiny, oh, this is cool. I haven't seen this in a while, but you can see it only sent 304 bytes over the network, which is awesome, right? That's kind of the power of this thing, right? Instead of having to send all 30,000 rows, it's just sending a few bytes, which is the result of these counts. Yeah, so I guess, what does this else say? The group by is just on a single node. The scan happened on all 3 of these nodes. Blah, blah, blah. So cool stuff. What I wanted to dive into today is looking at how these parts of the query are scheduled, right? It's pretty clear how this part of the query is scheduled, right? We, get the query, we start planning it, we start executing it just on the same node that we got it, right? But how do we actually start running this part of the query, right? On node 2 and node 3, the part that we weren't related to. And how does that all work? What are the APIs? What's going on there? Etc. So that's what I kind of want to dive into today. My alias name. How does CockroachDB manage all the geographically distributed nodes? Does it use any specific orchestrator like Kubernetes? That's a great question. So Cockroach isn't really opinionated about which distribution mechanism that you use. You can deploy it any which way that you want. And it will kind of run if you point the nodes at each other, give them their IP addresses. You can also annotate the nodes with locations. If you're familiar with other databases like Cassandra, you might remember how in Cassandra, you can tag nodes with localities and racks and data centers and stuff like that. And so, you can do the same in Cockroach. You can say, this thing is on the US East, this thing is on the US West. And using those tags, you can also ask the database to do different things with the data, essentially. Like, please make sure that this data has at least 2 replicas in US East or something like that. Or, you can come up with all sorts of crazy rules and stuff like that. But really, we're not opinionated about whether you want to use Kubernetes, whether you want to deploy by hand, whether you want to use, I don't know, Pulumi or, well, I don't know what I'm talking about. I don't remember the names of these technologies, but the point is that you can kind of deploy it any which way. We do have some capabilities with Kubernetes in particular, just because it's so popular. I think we're working on an operator, which I guess is sort of a little mini distributed system that helps you scale things up and down. We used to have a Helm chart. I'm not sure if that really works anymore since we're trying to move to this operator thing, but that's kind of the situation there. Yeah, so that's a great question, M. Salcantara. Very good question. Crayfix, thank you for the compliment. Hello, Flask. How's it going? My pirate. Is Helm like a dirty word? I thought Helm might have been a dirty word because like we're sort of trying to deprecate it, right? Yeah, so let me talk about what the aggregator sends, right? That's such a good question. Such a good question. You can see that like, how do you communicate? Oh gosh, I always do that. I'm still getting used to those Windows keyboard shortcuts. But anyway, you can see that in node 2, it has to know to do a table reader and aggregator. So what is the message that we send for that? We have a protobuf interface for this stuff. And if we go to this file called processorsql.proto, which is red for some reason, I think maybe my editor needs to be taught a little bit more about protobufs, but not important. We have these specs. We call them specs, and a spec is a instruction for a remote node. And so on the picture here, we can see that there's a table reader and an aggregator. And so what we send to the remote node is a message containing some specs. One is a table reader spec, which tells us things like which table are we going to be reading from, which is the index we're going to be reading from. Are we going to be reverse or not? What are the spans we're going to read from disk? Do we have a limit? I don't know what this one is. Something about scrub, some scan visibility, some other stuff, blah, blah, blah. But point is, this is kind of the idea. It's like a little instruction, maybe like a CISC instruction, since it is pretty complicated. And then there should be an aggregator spec as well. So an aggregator spec is the specification for an aggregator. An aggregator performs aggregation in the SQL sense, right? And so inside of the aggregator spec, I can have different functions, all these different aggregation functions that we support. I guess in this case, it would be a count rows, since we're doing a count star. So there should be a count rows somewhere. Maybe it's just called count down here. Oh, there it is, count rows. And inside of the aggregator spec, we also have some other things. Like I think you can have a few different aggregations happening at a time. An aggregation as a func and whether it's distinct and stuff like that. You know, which column are we aggregating over? Are there any filters? Are there arguments? Stuff like that. I think, yeah, so I mean, in aggregations, of course, you can have these like arbitrary SQL render expressions too. And for those, it's kind of interesting. We actually do use basically text to represent those right now, which is not exactly ideal. I think that's something that we might look into improving, but it also works pretty well. I forget where that's sort of stored right now. Might be in processors.proto. Nobody likes Helm, I guess, and YAML. M. Laswick, what's up? Don't use Helm, use JSONnet. Don't install things, use Flux. Wish I knew what you were talking about. These are like next level concepts for me. Metal Matse says something interesting, which is, I wrote Cockroach operator based on JSONnet. Wow, this is cool. Well, I don't even know about any of this, but this is amazing. I should, I'll send this around to the team. What is JSONnet anyway? It's a data templating language for app and tool developers. Generate config data side effect free. Simple extension of JSON. Oh wait, so is it kind of more of like a... Is it just kind of like a... data templating language? So it's like a JSON extension. That's cool.
Computers hooked into over 1,000 data banks throughout the world.
So it's like a way to make it easier to configure some of these really complicated things like Kubernetes or operators or stuff like that. JSON with comments. 50 lines of JSON that generate stupid amounts of YAML abstraction for Kubernetes. Very cool. Well, this is awesome. I didn't know you wrote all this stuff. This is really neat. I will definitely pass this around to the team because I think people would be interested to see it. So yeah, we've got this expression stuff, right? I just want to quickly find where that thing is defined. Maybe if I grep like... So exec infra pb data.proto, okay. So an expression is what? It's basically a version and an expr, and an expr is just a string. So this string, yeah, it's basically like a SQL fragment, and it's an expression, right? So in SQL we have kind of statements and expressions. When we say expression, we typically mean, well, or relational expressions or scalar expressions is another way of saying it. But when we say expression or scalar expression, what we mean is like, you know, something like, you know, 3 + 2, or like, you know, some func on like, you know, some JSON pointing at some other thing or something like that, right? So it's a scalar expression stuff as opposed to like a select or a limit or any of these kind of SQL higher level clauses. And we just store them as strings right now. And yeah, it's been working okay. You can write functions instead of relying on pure text templating. You use the cockroach operator based on JSONnet in production at Polar Signals. Oh my gosh, that's amazing. That is so cool. Yeah, Polar Signals, a lot of cool stuff coming from Polar Signals, right? You've got especially that really handy pb.gz share thing. I love that thing. That thing is really super cool. Yeah, there seems to be like a lot of these profiling solutions. It's a popular and exciting space right now. It feels like a lot of innovations happening there all at once, including from Polar Signals. So really cool stuff there. I would love to see an easier, just profiling, improving the kind of ergonomics of this pprof stuff and making it easier and better to play with. I feel like is a really profitable place to be in. Would be really helpful for a lot of people. My true dream is that we would have, for Go, kind of like a heap explorer, like they have in YourKit from Java. I don't know if you guys have used that, but man, it's incredible. And it's something that we really struggle with at Cockroach, is trying to understand what happened if, a cockroach, if CockroachDB runs out of memory, right? How do we deal with that problem? Who's owning the memory? Why is it retained? Like, has it not been cleaned up by the garbage collector? There's all these questions that are really hard to answer with the tooling that we have in Go. Dealing with Go heap dumps, it's kind of not possible right now, unfortunately, for various reasons. And having a powerful explorer for stuff like connectivity analysis and finding the roots of a particular object would be so good. So I don't know, Polar Signals, you guys are looking for something new to play with, but I would pay for that in a heartbeat. Still not liking Kubernetes as much. Most of the things I care about are somewhat stateful. NixOS without overlay file systems is enough. Okay. So what I wanted to talk about, right? What I wanted to talk about was what happens at these little boundaries, right? What happens at these little boundaries? I think trying to think about what would be the best way to start playing with some of this stuff so that we can all understand it together. I think what we should do, we're going to start up one of these demos again. We're going to do the same thing. I shouldn't have shut that demo down, actually. We'll just run through those same commands that we did. We'll do our create table, we'll insert, we'll do our alter. Whoops, we need to first do our split at, then we'll do our scatter. We'll do our show ranges. Oops, this was my test JSON. Show ranges from table A. Okay, so I think what I want to do here is basically come up with some statement. I want to do it through the profiler. I think the profiler is just such a good tool to explore what the code is doing and how. And so what I want to do is come up with something that forces these remote nodes to do a lot of work. I feel like maybe, what about like a select? I feel like all of this is going to be too cheap. It's all really much too fast. So I guess what we should do is make it slower by what? We could add more data. We could add more complex data. We could we could do like a big join against itself or something. What if we said like select sum of int of a1.b plus a2.b from a as a1 join a as a2 on true? Maybe that'll take too long. Anyway, this is going to put the database to task. Delete the 500 megabyte string you allocated at the start of execution as a reserve. pernos.co, what is that? Fast omniscient debugging. Record using RR. Yeah, so this is an interesting idea. I think the thing with recording using RR is it's pretty expensive, right? I'm not sure if that's going to be exactly what. So this seems like a good thing. This is a 30-second query. And so what I want to do is I want to run this 30-second query and profile it, if that's possible. And using that profile, we can explore what's actually going on. So let's see. I think if I say demo ls, it'll give me these different web UIs. So let's grab node 2. Well, let's first we'll say explain to SQL so we can understand what node we're even on. So this is the slightly more complicated plan that we're exploring now. It's kind of neat. Try to drag it around so it's easier to read. Always a fun time. Whoop! You gotta like, whoop! No, it's not possible. Okay, how about this is slightly better. This is like the dumbest thing. I love playing this little game where you like try to make the little graph a little bit more readable by sticking it around the... Okay, that's pretty good. Who likes force-directed layouts? Force-directed layouts, truly the most fun kind of thing to play with. So it looks like, well, this is actually looking a little bit not great because these remote nodes don't have to do all that much work. I was gonna say what we really want to do is profile node 3 and node 2, but look how little work they actually have to do. So that's not ideal. We need to figure out a way to make these remote nodes do a little bit more work. How can I make that happen? The problem right now... maybe we can say, how about this? What if I said select star from? Well, this is not going to be good. How do I teach these guys to do a lot more work? There should be, oh, maybe if I do like a sort, something like that.
I want to give you what I think is the most authentic recipe. So
As A of B, order by B. This is going to be bad too, though. This also is not doing what I want. Noack and Vinny999 and Seekvar. Thank you all for the follows, as well as Nico BCN. I think that's everybody. How do I like make, Maybe what we can do here is, let's take a look at some of our test cases. That would be an easy way of finding some good plans for this. So we're gonna go to dist SQL. Maybe we could do dist SQL. Ag, maybe? Does this have any plans in it? No, this is not the one. Dist SQL, ag. So we have all these test cases that I think in theory should have a bunch of hard-coded plans inside. And I think that some of these plans at least should be theoretically interesting enough to use as this example. Of course, can't really click on these. I'm running into all sorts of irritating problems here, you guys. It's really super goofy. Let's see if I can see, let's see. This SQL ag. Okay, how about like this? Okay, so here are some good ones. What does this one look like? It's an example. You know what I think? I think what we should do. I think what we should do is the following. We're going to use string data because it's a little bit easier to make annoying string data than it is to make annoying integer data. So let's go back over here. We're going to say create table, a int primary key, and then our B is going to be a text field. And we're going to say insert into a values or we'll say select G, and then we're going to just like insert some big strings basically. So we're going to say repeat A. Could just do kilobyte payloads, I guess. From generate series 1 through 10,000 G of G. Okay. So then if I said select some int of length of B from A, this is still far too quick. I guess I could just insert way more data. Okay, so let's just say 0 times 1 times 1. So we'll say prepare x as, and we can say execute x of 2. Dang it. Need to say one minus 10,000. 1 times 10,000 minus 10,000 or something. Is that right? This is irritating. I guess I need to say -1 on one of these as well. Yeah? There we go. Okay, so now I can just insert a little bit of data. This is annoying. I should probably just write a script for this, or I should be using TPCH data. I don't know why I'm being so lazy. I feel like sometimes when you're this lazy, you actually make your life more annoying, and you're not lazy. I feel like this is, I'm falling into like an anti-laziness trap right now. But anyway, so let's see, coming back to our original query. It's still way too slow. I think we need to load an actual data set to make this interesting. Yo, Brohanster, what is up? Other problem with loading an actual data set though is that I can't really use demo anymore, then I have to actually deploy real nodes, and that's like a whole pain. I think I'm just gonna keep inserting small amounts of data into this. It's because I'm so hyper lazy. Does this count as lazy, or is this anti-lazy to you guys? Have you ever just like typed a bunch of stuff into chat? Chat. Imagine calling a SQL prompt chat, by the way. What we really need is a way to run executes in a loop, but we don't have that because we don't have stored procedures. A smarter person would have made a script for this, huh? Okay, what about now? How's our count now? Is it slow enough? 200 milliseconds? If we do a sum, at least it's taking like 600 milliseconds. It's sort of, it's like, all right. Okay, so we're gonna say alter table. We're gonna split up our table. Show ranges from table A. We've got 2 ranges. Alter table A, split at values. Let's do like, okay, so then if we do an alter table A scatter. So now we've got, okay. We've got some ranges on each of the nodes. And now if we do our some int, and we can say explain to SQL on this guy. Okay, so we get a plan that looks reasonable. We do our render on the remote node, and we do our sum on the remote node, and that's taking like a small amount of time at least. 1 eternity later. Yeah, exactly. Can you use generate series with x of n? Unfortunately, you cannot. The execute thing, you can't really run that outside of a top level statement for like various complicated reasons that, well, it's really just like a limitation that we haven't lifted. Okay, so if I look at my different nodes here, I can hopefully go to one of their web UIs here. And if we go to the profiler, we should be able to look at a profile for this thing. So I'm going to click this and then just run this command a couple times to get some work into it. And hopefully we'll see something interesting here. Well, let's go ahead and move it into the graph mode, which I like better for most things. And so up top here, so there's kind of an interesting thing. Let me open one other profile at the same time here. I'm going to open the profile of sort of the main node that we're talking to, which I think is node 2, right? Is that right? We're actually talking to node 1. I guess that makes sense. So we're going to open up the web UI of node 1 here. And we're going to go to make a similar profile for node 1. So over in this tab, we're going to have node 2. In this tab, we're going to have node 1. And in node 1, I'm going to run also a profile, switch back and run this a couple times, make the database do a little bit of work, and switch to graph mode. And you should immediately see some difference, theoretically. Although you actually don't in this case. Why is that? Oh, you know what it probably is that since everybody's running in the same process, this experiment doesn't really work that well. Man, that's annoying. Everybody's running in the same process, so the profile is actually sort of to the same node, even though there's 2 of them. Maybe I really ought to have just made an actual Cockroach deployment with a few different nodes and stuff like that, and we should be playing with that. Maybe we could just look at doing that instead of this whole mess. It shouldn't be so hard. I feel like that would be better for like lots of different reasons. Well, let's take a look at this first real quick. So we just don't like ruin our whole experiment here. We can do that next kind of. The point that I wanted to kind of tell you guys about was that depending on whether we're local or remote, we're gonna be rooted. Like all of the work that we're doing is sort of rooted in a different spot. And you can sort of see this here, I think, because there are these 2 different boxes that are at the top. And if you guys aren't familiar with reading these charts, it's basically like, this is basically just a stack trace. And towards the top is the top of the stack trace and the bottom is the bottom of the stack trace. And so the fact that there's 2 arrows pointing to the same box here, it basically means that there's 2 callers that are calling into basically the same pipeline. So if I were to focus on this one, I wish it would show you some of this stuff here. Maybe I can see that in the flame graph view. Yeah, so you can actually see this more clearly on in the flame graph view, which is unusual. I normally like the graph view, but in the flame graph view in this case, it's actually quite a bit simpler to understand. I'll make it a bit bigger. You can probably not read it too well. But basically, you can see that on the left, we have the work that's happening in the main node. Coming back to this plan here, you can see what the plan is doing is it's doing a table read, then an aggregate, then another aggregate, and then a response. And so you should be able to see that same thing on this flame graph. You see that here, right? So what you're seeing here is we're rooted actually at this unordered synchronizer thing, which is this little component. This unordered thing is our unordered synchronizer. And so interestingly, like this is the work that this guy is doing on the main node. It's the same as the work that's happening on the remote nodes, right? It's just rooted in a different thing. On the main node, there's a go routine that this unordered synchronizer is running. So it's doing its work, and then it calls down directly into this ordered aggregator, which does a bunch of stuff, and then it ultimately does a scan of the node on disk. You can also see this is where it's doing its like string counting operation over here. And there's like various other things going on. But on the remote nodes, right? On the remote nodes, we see something different. We see that we're rooted in something called an outbox. And this is what I wanted to kind of explore a little bit more today. What is an outbox? An outbox is basically the thing that allows data to be sent across this like node boundary here. You can see there's an aggregator, there's an arrow pointing from the aggregator to the synchronizer. And so like, what is the code that's like sending across this network boundary? And that's what we call an outbox. And as you can see in this thing, the outbox is basically the go routine, the like root of this particular go routine. There's a little bit of infrastructure up top. There's some like accumulate async component stuff, but you can kind of see that there's like an anonymous function in there and there's something a little suspicious going on. And the main thing that's actually happening is this outbox thing. And what is the outbox doing? It's saying run with stream, send batches. some runtime error catching, send batches func1, and then it just basically calls back down to the same stuff that we saw the first Go routine calling into, the aggregator, the projection, and the string counter thing. So actually, why don't we go ahead at this point to look at what this outbox thing is actually doing. I feel like that might be interesting for us at this point. And this is call our PC outbox. I guess we have two files named outbox. That's a little confusing, but that is okay. Flame graphs are really nice. Stop using the graphs at this point. pprof node graph view from perf record samples. I bet you can. Perf pprof. Check this thing out. Perf data converter. Tool to convert Linux perf files to the profile.proto format used by pprof. I bet this thing's your ticket, Nami. I've linked it. Yeah, I mean, the flame graph is great. This thing is great. They're both great. I think that this view allows you to see, it's more of like a bottom-up view, whereas the flame graph is sort of more top-down, right? Like this graph like accumulates all of the different paths to something like this random low-level function that you're calling a lot. Whereas on the flame graph, it would be like segmented across many different spots. You'd see it over here, and you'd see it over here as well. But yeah, and here, I mean, this basically shows you, okay, the workload was just doing a lot of string counting, right? 36% CPU used in rune count and string, just because we were summing up all of that string data's length. So what is an outbox? What is an outbox is a good question. So in this, I think the reason that there's two implementations of it in Cockroach is kind of that we've got these two engines, right? There's this vectorized thing, which is what we were looking at last time with JSON. And we've got our sort of older row at a time engine. Nikon, what's up? Welcome back. Nice to see you. So I think there's one outbox per each implementation of this execution engine, one for vectorized and one for row engine. And so I think since we're kind of trying to deprecate the row engine, we'll just take a look at this one, which is the column-oriented one. What does the comment say? Outbox is used to push data from local flows to a remote endpoint. Run may be called with the necessary information to establish a connection to a given remote endpoint. Okay. So the struct, it's got some type information. It's got some converters and serializers. This stuff is important and interesting and definitely something that I wanted to dig into here a little bit today. I think that there's a big performance optimization that we can do inside of this part of the code, which is basically the part that takes this vectorized batch data stuff and shoves it into a network compatible format. We sort of chose Arrow, which is this, I don't know if you guys know about Apache Arrow. It's this like specification, I think, for a columnar data format that is serializable, kind of in the in the byte sense, not in the transaction sense. And so we kind of use it to implement how we're going to serialize that data over the network for sending stuff like these integers across the wire, or probably in a more interesting case, like if we were sending strings and JSON and tuples and arrays and complicated user data. So yeah, it's got these converters, these serializers, then it's got some other stuff, I don't know, some state variables, maybe some tracing information. And what does it actually do, right? So when we click run on it, what does this say? Run starts an outbox by connecting to the provided node and pushing calldata.batches. So calldata.batch is the name for the data structure that contains our vectorized data, our columnar data. So pushing these batches over the stream after sending a header with the provided flow and stream ID. An extra Go routine is spawned so that receive may be called concurrently with respect to the send Go routine to listen for drain signals. A very important point. A very important point. So the question, right, is about cancellation. This is kind of a fascinating point, but let's say you're doing some big complicated query and somebody says, I want to stop doing all that work. What actually happens? What's up, Matrix Master? I probably need to update this for today. Haven't done that yet. We'll say commands edit project, we'll say exploring the distributed in CockroachDB's distributed SQL. Maybe if we come up with a PR to do here, I'll add that as well. But the keyboard layout, if you look at my GitHub, you can see the keyboard layout. Is that stopping the SQL statement by canceling the context.context I pass along? Yeah, exactly. So Metal, exactly right. Ultimately we want to be canceling context, and contexts are being listened to at various points in the stack. So for example, what's interesting is you can see it even in the flame graph, I think. There should be something called the cancel checker. So check this out. Call executils that cancel checker. So if I go looking for this cancel checker thing, what I find is it's a little struct, an object for repeatedly checking whether associated context has been canceled or not. And what it does is it has a single method called check, and the check, I guess, lets you have an interval so you don't have to call it every single time. It'll check it every 1024 times or something like that. But I think there's also a way to just check right now. And we actually check this thing a lot wait a minute. I think that there's maybe 2 cancel checkers, right? This is the theme of the day. We've got 2 implementations of everything right now, but here's the columnar one. And you can call check every call to like check this thing. And we have these calls sort of sprinkled around in lots of different places. Like maybe in the sorter, we've sprinkled a call to cancel checker in the middle of the sort to make sure that we don't spend too much time sorting. So if somebody cancels our context, we really ought to notice. So that's an important thing. But the question is, really, it gets a little bit more complicated with this distributed stuff, right? Like, it's easy enough to have a single flow get canceled if you cancel a context, but how do you cancel all this work on a remote node? And the answer is that we are sending these messages and these sort of signals back and forth across these network streams, which are bidirectional. And if somebody cancels this main query, it's going to send like a drain requested signal, I think, to these remote nodes. And if we're not listening on these, we won't notice that we're being canceled, and we won't cancel. So it's pretty important. So actually, why don't we explore that? The extra go routine is spawned so that receive may be called, right? So where do we do that? So what does the outbox do? It says, and what's kind of also funny, by the way, about these outboxes is that they're often spawned on remote nodes in the first place. So like this guy, to set everything up, he's like, hey, node number 2, please make an outbox. And the outbox is going to reconnect back to the made node. So it's a little weird, right? It's like, why? Yeah, a little odd. It's like almost as if we should be able to avoid having to redial in a sense. But I'm not sure if that's too possible. Right, so we dial this other node, we get our connection. Maybe there's some, gRPC has all sorts of connection multiplexing stuff that it does, so presumably it doesn't waste too much, but who knows? It makes some dis-SQL client, it makes this flow stream thing, and then at a certain point, it's got to start a go routine, right? Maybe it's inside of here. Yeah, so inside of run with stream, we actually launch a new go routine, which is this go func, and we're just sitting here listening on the stream. And we're basically just listening for either errors, in which case we leave, we get a connection error, we leave, or we get some handshakes or some drain requests. And this is kind of the killer thing right here. If we get a drain request, what happens? Drain request is like, you're done, I don't need any more data from you. We switch some variable and then people listen and stop doing work. But yeah, a little bit tricky. And then down below our receiving go routine, I guess there's even more stuff. This is like, I think this is like our little loop. This is, we call send batches. Send batches is basically the thing that actually runs the SQL, right? So, and we should see that in our flame graph. You see we've got the send batches. Inside of send batches, we're just in a loop, right? We're saying for with no end condition. We say input.next, which is saying, hey, aggregator or deselector in this case, give me your next data. I get my batch. I convert my batch into arrow format. and then I send it over the stream. And I keep doing that until I get an error. Root guys like, do stonks? I think that, yeah, hopefully you guys are all gotta invest long, you know, buy and hold. That's the way to accumulate wealth, unless you're trading Dogecoin. In this case, I don't know what to say. Yeah, so that's kind of the deal, right? We're doing this loop, we're asking for the data, we're converting it into arrow format, and we're sending it over the network. What happens when we get errors is a question. Let's say we got an error when we're sending data over the stream. We call some handle stream error. We've got some switches here. If it's an EOF, we cancel ourselves. And we actually found a bug recently. So the bug is that it hasn't been merged yet, but the bug is that we really should also be canceling the context here. And we're not. So it's like a really subtle problem. But the trouble is that if, let's say a node goes away, see ya, Metal Mate. Thanks for stopping by. Enjoy your pizza. If we do get an error while we're sending, and it's not an EOF, so we get some sort of other more nasty error, we should really cancel ourselves and move on with life. But we weren't doing that. We're gonna fix that. So this could lead to kind of some weird things like orphaned flows. Like I think it could lead basically to a case where this guy would still be spinning, you know, doing its work, and it wouldn't be canceled even though this node went away or something like that. Something kind of nasty like that. So we'll fix that. But yeah, so I think what I wanted to look at a little bit though was how we do some of this serialization stuff, because I think that there's probably some opportunities for enhancement here. So we've got this batch to arrow business, right? Here's our batch. Let's take a look at batch to arrow. So batch to arrow, it takes this call data.batch. We've looked at this a lot on stream, right? This is like our mem batch, which has basically a slice of vecs, and these vecs can be booleans or ints or int64s or whatever it is, like basically, and they all kind of boil down to these just like slices of data at the very bottom, these really tight columnar data structures that we like because they're super fast. And so what do we actually do here? And how am I gonna, we should really look at some benchmarks. I feel like that's what we should be doing now. We had some fun with this profiler, and I think what I want to do is maybe find some benchmarks to play with. We've got to have some benchmarks of this thing, right? Arrow batch converter. Test. What about a bench? Benchmark arrow batch converter. Why don't we take a look at this guy? This should be fun. So arrow batch converter. Wait, I wanted to look for the benchmark. Benchmark. So we're gonna say make bench. Bench is equals benchmark arrow batch converter. Package equals package call security. Yeah, I don't know. We're kind of just like all over the place today, you guys. We're just looking at we're following our nodes, seeing what we find interesting. So this is kind of weird, right? Like what's going on here? What is going on here exactly? We have our booleans, which seem like a reasonable speed, a gigabyte a second of serialization. But then we have something very suspicious here. Our bytes seem to be going at 440 gigabytes a second, which seems impossible, right? So maybe something is up to investigate with in this benchmark. Some of these numbers are a little bit suspect. I think maybe it's that since we don't actually have to do any work, in some cases, we just like are copying pointers around. It looks like it's really fast. It might be something like that. So timestamps pretty fast. Decimal's pretty slow. We know our decimal implementation has some work that we could do on it. That was one of the projects we started on stream and never really finished, trying to improve our decimal representation, but hopefully we'll get there. Hey, Big Neil, if one wants to get into distributed computing, what should be an ideal roadmap to follow? It's a good question. Maybe it depends on what your goals are. Are you interested in learning more about distributed systems, or looking for how to get jobs, or tell me more about what your goals are. What's the second column? The second column is the number of runs that the computer did of this benchmark. Couch941 and iFoxy Fatima, thank you guys for the follows. John Eck, we're basically investigating some of the code in CockroachDB that allows us to talk in distributed fashion between nodes. So talking about how does the database send data in between these two nodes in a plan like this. What's up, Easy Light? Oh yeah, so what I wanted to actually do here is not just look at the code, but I wanted to look at a profile of this one as well. So why don't we pick one to look at here? Let's pick, which should we pick? Timestamp maybe? Timestamp, null fraction equals 0.25, let's say. Then we'll say test flags equals CPU profile equals CPU.out, mem profile equals mem.out. This is a way for the database, or for the benchmark, to just dump some profiling information about what it did. Oh, and it actually has a benchmark for both directions. So why don't we just pick batch to arrow for now? Batch to arrow. Caution of micro benchmarks. Yeah, the micro benchmarks themselves they're a mixed bag, but using them as profiling tools can be pretty good. Like looking at the profiling result, especially. Learning more about distributed systems, subject core matter, interested in learning more. I think you should, I have these DB books commands. These are good ways to start. I especially like the, I mean, all of this stuff is really good. The database.dev is good. The designing data intensive applications is really good, and Andy Pavlov's course is really good as well. Maybe take a look at those. So we're gonna say pprof, http localhost 8080 cpu.out. So let's take a look at localhost 8080. So this is kind of what we're doing. Is timestamp an interesting one, or is this just too specific at what timestamps do? Let's take a look at what this time Marshall binary is. Where does this live? This is in batch to arrow special type. I see. So I guess this is the code that says for each type, how do I build an arrow batch for a given for that type? What's up, NickCon12? Thanks for the follow. So looks like what we basically do here. We do these append nulls. That seems to be very cheap. Like we're spending no time in append null. We spend most of our time in time.marshall binary, which is interestingly something that we don't actually control, right? This is something that's part of Go that we're using to write down the timestamp, basically. So I feel like it's not really fruitful to look at this too much. Although I do think that it's interesting. Like, why are we allocating new objects inside of this thing? Is it this? It's like a little bit suspicious, right? So if I click this guy and I click view source. Oh, you know what I could also do is let's look at the mem.out. That's going to show me what actually got allocated. Oops, mem.out. Yeah, it looks like we allocate so much in this thing for some reason. It's like a little bit suspicious, right? How do I get view source? So it's actually so interesting. It's allocating a byte slice to give back to us, and that's just so odd that it doesn't seem to allow us to append. You know, I mean, ideally what we could do is pass in a byte slice that we're already going to write to, right? Because like, what does this code actually do is in the end, it says, give me the byte slice, and then I append it, right? It's almost as if we'd prefer to have this guy write directly to this guy, right? It's a little bit weird. A little bit weird. Easy Light, how is the progress in replacing make? What was the CLI tool you wanted to replace it with? So we're using Bazel. It's still in progress of a project. Definitely not there yet, but the plan is to use Bazel for that. It's still kind of going. It's still an ongoing project though. It's kind of a big project to change all that stuff. It's going pretty well, I think, but it's going to take a little bit more time. So it looks like we have this like distinction between special type and non-special type. Why is that? It's because for these certain types, we actually get to do something very, very cheap, which is that we just pass a pointer around to the slice, which is really the ideal thing, right? We don't want to have to mess around so much and copy things all around, because in the end, I think what happens in this outbox is that we get this batch to arrow thing, and then we have to copy it out, right? We say o.serializer.serialize. And I think what this actually ends up doing is it probably has to copy it all, right? It says w.write buffers bytes, right? And this is actually... Who are we writing into here? We're passing it into a scratch buffer, right? Yeah, so this is kind of intense, right? Basically, we do all this work, we make all these new bytes, we allocate all this stuff, and then it's only just to copy it all into this new scratch buffer. Then we copy all that into another spot, and then we send it out, right? So there's a lot of sort of waste here, and I wanna improve that. I feel like that could be a really big win. Just not sure how easy it'll be. But you know what I mean? Like, doesn't this feel wrong to you guys? We do all this copying, and we copy again into this serializer. There you go. It's the music. I should add like commands add. How do I make an alias? Yo, Dirter, what's up? I think that the reason that this is supposed to be cheap is that this batch to arrow thing, this is always supposed to be free. And it's free in some cases, like in the case above where we had this really outlandishly fast result, this thing. So in this case, right, we're looking at converting a bytes column into an arrow batch. And doing this is absolutely free because we don't copy any actual data. We're just passing pointers around and pretending that we're copying. And so that's why we get these fake looking speed results. Like we're doing 447 gigabytes a second because we're not doing any work. And then later, yes, it then copies this into the like scratch buffer thing that we actually send. And I think that copy is required probably. But everybody should be doing this free thing. All of these ones where we're doing a reserialization, this is like very wrong. And we really ought to figure out a way to improve that and get rid of it. But trying to figure out how to do that, it's not exactly obvious to me how we're going to do that. You know, the other thing that's really confusing here is that, like, what actually happens in a call like this, stream.send, right? Like, we've got this big message. We just made this huge batch. We copied it into a byte slice. We wrote it again or whatever, and then we send it. Like, does this end up having to do yet another copy? What does this do under the hood? Client stream.send message. I'm assuming we're going to be doing client stream. So M here is an interface. We do prepare message. So, like, what is this in code? It's very sus. Very, very sus. Marshal and compress. Feels like another copy, doesn't it? Feels like another copy, doesn't it? Really feels like it's another copy, which is very sad for all of us. Okay, here's what we're gonna do. Here's what we're gonna do to improve this. Okay, this is gonna be really cool. Not improve, but to test it. We're gonna say, crap, did we get rid of that? I think we got rid of that demo where we had done all that. Okay, this is a good example where we should probably just make a real cluster and play with it that way. So let's go ahead and do that. We'll just rebuild the database here and make a remote cluster somewhere and kind of play with it that way. Roach prod create. Yeah, so I think what we'll do is we'll put this binary up into this remote node. And we're gonna go ahead and basically write a query that it doesn't even do a count star. It's just gonna like stream a ton of data from the other nodes back to the gateway. And I think that's gonna exercise the serialization code. And then we can look at all these copies, I think, because it's kind of hard. These micro benchmarks like don't tell us quite enough, because they tell us just this little one part of it. But I'd like to see it all in aggregate. I feel like that would be more interesting. I feel like I'm wondering, like, yeah, so I got the second vaccine today, and the question is, if I start feeling sick, will that be on the stream or off the stream? Like, I wonder what the average time to start feeling like second vaccine symptoms is. I was thinking, like, I'll start to feel sick halfway through the stream and have to be like, guys, I gotta go. I'm feeling horrible. Hopefully that won't happen. Okay, so we'll do a roach prod put. Jordan test cockroach. I'm not sure what the status with the Germany vaccine is, but it doesn't sound good. I hope you got it soon, Easy Light. 4+ hours. What's up, Maweef? Yeah, it could be 4+ hours. We'll see. I have a friend who got their reaction after like 18 hours. They got like a fever 18 hours later, which was pretty surprising. But who knows? So we're going to do Rich Prod start, Jordan tests 1 through 3. Is that not how that works? I haven't used this stuff in a little while. It's like this. Well, this seems to be an issue. libtinfo.so. I didn't really prepare this part of the stream ahead of time. I feel like maybe trying to, man, it's just too bad. It's just too bad. I guess I could just keep doing it locally. I guess that's what we'll do. 'Cause I don't know how to debug this right now. You got to do build builder. Okay. Man, I don't think this is gonna work because I don't have Docker installed on this thing. Okay, it's not gonna happen. It's not gonna happen. That's okay. That is okay. We'll just forget this thing for now. What the heck is up with these? Are these like fake covers of like famous songs or something? Okay, so forgetting that idea, let's just go ahead and we can use this local thing. So we'll say roachprod start local, right? Does that work? Roachprod create local like this. Okay, there we go. So then I'll say roachprod put local cockroach. There we go. Okay, this is going to be a bit easier. There we go. Okay. So then we can say roachprod put local for workload. We can say roachprod run local for bin workload run KV like this. All right. Okay, so sorry, that was like completely random. But basically what I'm doing is just setting up a little local cluster so I can put some data into it and then I can play around with it, do some benchmarking and stuff like that. People over 70 or 75 in Germany, 4 groups of priority, didn't finish yet. 3rd group end of May. Unknown when children will be vaccinated. Yeah, takes time. Oh, well, at least there's progress. Been studying about database development some time. Abstract idea seems fine. Implementing is super hard. Develop your own database is a cool idea or better to hack existing one? I think you should. It's a good question. Honestly, people ask this a lot. I think that you should see. I would try that course, right? I'm always linking this course. Have you, whoops, DB books. Have you looked at this course, this UChicago one, this CockroachDB thing? I feel like if you actually try that, you might, it's going to be a lot of work, but you would learn a lot, right? It's like, always these things are like, the more effort you put into it, the more you're gonna get out of it. And I think this one's like a high effort, high reward kind of thing. Probably same with whatever Andy Pablo's thing is, which honestly I'm not too sure about. If I say roachprod SSH Jordan test 1, does that work? Might not. Where does roachprod local put your stuff is a question. Okay, so if I go to local. Oh, wait a minute. What am I even doing? I need to say roachprod SQL local one like this, maybe? There we go. Okay, so show create table KV, use KV, select count star from KV. Okay, so I have like some small amount of data in this thing. But the point is that I actually will have a real cluster to play with at this point. And I think what I wanted to try to do here, I should probably put more data. What I really should do is load a TPCH data set onto this computer. But let's say prepare X as select star from KV. Then if I say execute X discard rows, I think, does this work? It's really much too quick. But I really do need some sort of like better data set to play with here. The problem is that I just don't know if I can feasibly get TPCH installed from this machine without looking at instructions, which I don't feel like I have access to on this machine. So there's like some slight difficulties here. Big Neil says, I was thinking of following this roadmap microservices. Oh, what's up, Sedana? Roadmap microservices or gRPC, add Kafka or NAT to the microservices. Maybe learn containerization. Would this stack with some projects be enough to land your first job? I would say definitely. I think if you have this background and you have studied things, I mean, it depends on depends on a lot. But having this experience under your belt, this is going to be a huge experience for your first job. I think it's probably not so super common that, I don't know where you are in your career or anything like that, but having all this experience very early in your career, I think is a big advantage. Seems like a good plan. Yeah, so I know that. I wonder. Hold on a minute. Don't we have something that allows us to like generate TPCH data without having to download it from some like random spot? Did I make that up? Did I make that up? Post load. Well, let's take a look here. What if I say roachprod? Well, I haven't used this stuff in like too long. Oh wait, what I wanted to say was roachprod PG URL local one. So if I say it and then bin workload, or even better, I feel like I could just say cockroach workload h init h. Yeah, see, it doesn't have like a way to init with TPCH, and I don't know why that is. It doesn't currently work with the inserts data loader. Try data loader equals import. I feel like there's no way this will possibly work. Oh, it does actually work. Oh, this is sweet. Why isn't that the default? The heck? Powell, the Lubartoa, thank you for the follow. Alabor, thank you for the follow as well. Sophomore year student. I think you should take a look at trying to get some internships at companies that do stuff like distributed systems. I feel like I've seen a lot of success with people doing internships at places like CockroachDB. I feel like that's really good experience, and a lot of the interns that I've seen, yeah, I mean, they get a lot of this experience under their belts pretty early, and I think that's really powerful stuff. So take a look at doing some internships. I think that, there's a lot of power in doing things by yourself as well. But I think sometimes getting some structure, getting some people to give you some projects that are relevant for them can be a good way. I think it's going to be really hard to find, like, what am I doing playing with distributed systems? What is like the purpose of my work right now? Finding the purpose of that work can be a challenging topic unless there's some reason. There's a company, or there's a project, or there's a website, or there's a service that you're looking at, right? Like having those things around as kind of a target can really help with what you're playing with, I think. Oh my gosh, okay, this was amazing. I didn't have to mess with any downloads. And I think what this says now is that I can say roachprod SQL local 3, and I can say use tbch, and there should be some stuff there. Oh my gosh, this is amazing. So if I say show tables, say show ranges from table orders, hopefully we'll see something good. We see something good here. And now I think, hopefully, let's say prepare X as select star from orders, execute X, discard rows. Okay, so that at least takes like at least half a second. So that's enough to work with, I think. That's going to be enough to work with. So let's go ahead now and say, we're going to say, can I do explain? Oh, I can't use explain execute though. That sucks. But that's okay. We can just say explain dist SQL on this guy. Open this up, and what we see is this. It looks like we're connected to node 3, and we have to go to both node and node 2 to get this information, which is perfect. What we want to do now is profile node 1 to see what it's having to do all this serialization work, right? That's what we were looking at. All this serialization, all these copies, what are we doing there, and how can we improve it? So let's take a look at this node 1 guy and see if we can, and profile it a little bit. So how do I figure out what node 1 is a question. Oh, I guess it's probably just node 1, so to speak. So we'll leave this guy open. We'll open a new screen session here, and we're gonna say roachprod pg URL local 1. Or I guess I really want the, like, isn't there like an admin URL? I don't know what happened there, but that's okay. Point is, we have this website here. We can go to advanced debug. We can go to our pprof, and we can finally get to profile this thing. Sorry, I feel like this has been taking forever, but I feel like we're about to be onto something good. So we're gonna hit this. We're gonna switch back over here. We might need to do it again. We were a little too slow. So what we want to do is we want to do this prepare again. Use tbch prepare, and we're just going to execute X a bunch. So we'll go back. We'll try this again. We'll take another 5-second sample here. Then we're just going to basically run this a bunch. A little bit of unscientific way of generating work, but that is okay. We could even be doing much better, right? We could be using real tbch queries, using the workload generator, but I like to keep it simple for now. Okay. All right. We're definitely onto something good, you guys. So we're definitely onto something good, I think. Well, actually, what I was hoping to see was anything involving the serialization, and surprisingly, I don't see anything. See a bunch of mem moves. What's up with that? What's going on here? So let's come back to the flame graph. How come I don't see anything? Is it all just, is it in here? Okay, so maybe I picked a table that has really, okay, wait a minute. So show create table orders. So we've got some ints, some chars, some floats, some dates. And maybe all of these cases are the fast cases, right? We were talking about fast cases and slow cases, weren't we? So we have, here's our batch to arrow. So our fast cases, we know bytes is fast, we know int is fast, and we know float is fast. Okay, so maybe these ones are actually not problematic at all, and we shouldn't care. We didn't do any bools, we didn't do any decimals, we didn't do any timestamp TZs, didn't do any intervals, and we didn't do any like generic anything else things. Okay, well, don't we have some decimals in this workload, or do we not? No, we converted them all to floats, didn't we? Because we knew our decimals were really slow. Well, this is not fun. This is not at all fun. I guess. Oh, I know what we can do. We can sort of hack it. We can force this thing to use a Boolean by like putting some projections in it or something like that. So let's go ahead and say, we'll say prepare X as select star, comma. We'll say total price equals, we'll say cust key equals order key or something. So O order key is equal to O cust key. So this is going to add a projection that just checks whether these two things are the same, and it's a Boolean. And we know that, you know, backed in this sort of special case code, there's some special thing for Booleans. And so maybe this will be slow enough. Or, you know, it's even better. Let's turn one of these floats into a decimal. Let's do that. So select star, comma, L tax decimal from orders. These decimals are going to be really bad. I'm undecided what I want to do here. Maybe we'll do both. We'll do an L tax equals decimal, and then we'll do an L order key equals L part key. So we can get a little bit of both in the mix. Okay. We do this. We'll have to deallocate X. Do our prepare again. L tax does not exist. I was in the wrong table here. So I guess I want to do O total price. O total price. And then this thing needs to be adjusted as well. I think this is O order key equals O cust key. Okay, so now we're going to do execute S discard rows. It's quite a bit slower, which is great. We love slow for profiling. We'll do our profile, and then we're going to hit this a couple times. COVID into consideration, are internships going to be in office or remote? That's a good question. I think definitely things are mostly remote for the time being, but that may change over time. Okay, so now we at least see a slightly more significant chunk of time spent in the arrow batch converter area. Interestingly, we still see almost nothing in this record batch serializer.serialize thing. Because it's all like a fast mem move, I guess, which is interesting. So there's no allocations in here. And then the other question I had is like, what about when we actually send the message, right? What about the copies there? And you can see there's quite a big chunk here where this prepare message, this encode, the marshal, right? And this is allocating, right? So how do can we do better here? I don't know. But I guess to start off with, why don't we go ahead and look at this? Well, maybe that is what we're gonna focus on now. Maybe this is, we don't need to, hold on a minute. I mean, like 3% of the runtime was doing this send message stuff. It's just really not that much. So any... I don't know. I'm a little confused. I'm a little confused here. I think what we want to do, let's take a look at this send message again, because I did see something kind of interesting there, right? I saw something very interesting, which it said, where is this? Client stream, prepare message, right? And so prepare message was expensive, wasn't it? Did I make that up? Let's focus in on this send message thing. What's up, Travua? gRPC. So this gRPC thing is basically a RPC framework that allows people to send network messages to each other using some stream multiplexing. Yeah, grpc.io is what the website for this thing is. So what are we doing, right? Like, so prepare message is like half of it, and with retry send is half of it. And inside of with stream send, it does some allocations and then it writes to this HTTP client. You know, it just feels like, right. So half of the time is spent in prepare message, and check out what prepare message does, right? It has a fast path that we don't use. It says if prepared message is a prepared message, then we're done. We don't have to do any encoding. You know, this is intriguing. Otherwise, we do this in code, which I think is where all the time is spent, right? In code, compress takes no time. So let's look at encode. Inside of encode, we do this Marshall, right? Inside of Marshall, I mean, we're doing crazy stuff here. We're producer message.marshall. Producer message. Marshall. No, it's Marshall to sized buffer, I guess. Yeah, so what do we do inside of Marshall is that we actually make a byte slice. Check this out. Isn't that suspicious? We just allocate right here, but we have all these byte slices already, and it's perhaps that we should be able to find a way to skip this allocation altogether. Wouldn't that be nice? Like, there's no need for this, I don't think. What's it doing in CockroachDB? Yeah, so basically, let's take a look at a graph like this. This is a distributed query that's running. You see there these boxes. There's node 3, there's node 2, there's node 1. And if you run a SQL query that requires data from all 3 of the nodes, then we can actually push down filters and other computation to those nodes. And so we use gRPC. Well, we use it for more than just this, but in this context, yes, we use it to make these messages between the nodes happen, make the distributed SQL query. We also use it for any other communication between nodes, yeah. So not just SQL, but pretty much everything. So what is this prepared message stuff? Can we utilize that? That seems like kind of neat, honestly. This API is experimental. Okay, wait, let's take a look. I'm curious. What is this? gRPC prepared message. If the time to serialize and compress message is less than the time to transmit it, a single stream is capable of saturating a network connection. This is because in gRPC Go, the n+1th message can be serialized and compressed while the nth message is being transmitted. However, compression is slow. System parallelism. Do we have this prepare message API? Or is this really just about parallelism? You know, the annoying thing is that the fact that we have to keep making these new buffers is really irritating. It just seems sort of irrelevant. Okay, I'm gonna take a quick break, guys. I'll be right back. Just like a couple minutes. We got a troll in the chat, dude. Ivan MRCP, you trying to get banned, dude? What kind of thing is that to say? What kind of thing is that to say, my friend? It is unclear. Yeah, so I just wonder, you know, I just wonder about this stuff. Like, can we avoid these allocations? Can we avoid these Marshall allocations? Yes or no? Yes or no? Right, so we have this Marshall to size buffer, right? Can we get a size buffer up in here? Who calls this thing? A Rust guy? Our Microsoft. Yeah, so it's kind of interesting. We've got a couple of different ways that we can call Marshall that aren't just Marshall that causes the allocation. The question is, can we get this inside of gRPC? I feel like the answer is like almost certainly not. Which is, it's a little sad. It's definitely a little bit sad. But, you know, I mean, it's like, what is the deal with all this stuff, honestly? It's like, I guess maybe it's a little bit difficult to make this properly work because you don't know when the memory will be released when you send it over the network. I don't really know how that part works in in gRPC? Like when do you finish sending a message? I don't really know. But you know, it's pretty clear that like what is this interface that we're using anyway? So it's maybe client stream. Client stream lets you send a message, receive a message, context, close send, trailer, header. That's it. So it doesn't let you do anything sneaky like you send a raw message or anything like that. That's a little bit unfortunate. But right, the whole point is that it does let you, if you do send message on a prepared message, then it skips it. Then it skips it, which is very, very interesting. It's very, very interesting. The only thing is, can we mess around with these prepared messages in a way? Yeah, the thing is that you don't seem to have like public access to these things, so it doesn't look like you can pre-allocate them or pool them or do anything really smart. So that's kind of a bummer. It's definitely kind of a bummer. gRPC was atomic. You need to explicitly do streaming. Yeah. I mean, I think you're right. We do ask for streaming in particular. I just meant to say like when you send a particular message over the stream, when is that thing sort of finished, and when can you reclaim the memory and use it again? These are questions that Rust people have to ask all the time, Ivan, and Go people do not have to worry about. So how about that? There's one advantage of the garbage collection. You don't have to worry too much about the lifetimes. It's just a real problem to have, but I guess I won't go there. I won't go there. It's just a little sad, you know. I think this is a sad situation. It's really quite sad that you can't have any sort of faster access to this stuff, you know? It's like, it's just such a bummer. I mean, on the other end, maybe it just doesn't matter, right? In our actual profile, right? How much time is spent doing this stuff? Basically none of it. Basically none of it. What's up, Yoda Droid? Basically none of it. You know, 2%. 2%. But like, you know, I mean, 1% of your runtime spending allocations on allocations that aren't necessary. That is a bummer. What about this send message thing? What is an out payload and why does it have to allocate? What is this thing called? Send message. Basically in the same spot that we were before, but it's a little different maybe. You know what? I mean, I suppose maybe, can you implement your own client stream? Looks like maybe. Could be a way. Could be a sneaky way to be doing better, but it sounds like it's probably pretty hard. So whether we try send message. It's like, I guess in this thing, right? So inside of this thing, we do out payload. And what is out payload? It makes an object. Okay, nothing we can do about that. Cockroach seems to have awesome profiling tool like FlameGraph, similar ones for Postgres. You know, I don't know. Postgres, like pprof. Truly, I don't know. Postgres profiling, FlameGraph, profiling with perf. You can use perf to do it. We were just talking about transforming perf profiles into pprof profiles. I don't know. I don't know how easy it is to do this stuff on Postgres. I haven't really played around with it. Oh, did I say Postgraph? Postgres. Did I say Postgraph? I don't know what I said. Anyway. Oh, so this is if a stats handler is not nil. So that's interesting. I guess the point is that we've populated one of these stats handlers on purpose, and it's because we want the stats. So that's good. And besides that, you know, everything's chill. We do our write. We do our transcend and then stuff happens.
The data bank's too big.
Stuff
I haven't
happens.
done the search.
Oh, you're the one who messed up. Okay.
Guessing.
RJ, thank you for the follow. Man, this thing is bumming me out. This thing is bumming me out. I guess there's nothing you can really do about it. So what if I search for like gRPC Go allocations? What's up, Chad Nauseum? Let me update this actually. So commands, edit, project, trying to optimize the network marshalling code paths for CockroachDB. Cockroach is kind of like Spanner. Yeah, it's kind of like a Spanner related thing. It's a distributed SQL database. Similar to Spanner in some regards. One big difference is it's open source and you can run it for free. You went to a presentation once where someone pronounced gRPC. Oh, wow. Yeah, gRPC is not great. I feel like there is a common thing in the Go community to like pronounce these like short acronyms as words, right? There's the whole goose and garch thing or whatever, which disturbs me. I feel like there's other examples that I can't remember right now. But yeah, I'm not sure how I feel about that exactly. It's kind of like gRPC Go, like client stream allocations. Captain Proto. Yeah, so Captain Proto is really cool, right? We use this thing called flat buffers to help with some of this stuff, which is pretty similar, but it's not really helping here because we we don't really have a way to have flat buffers. gRPC doesn't seem to have a way to just like eat the flat buffer and write it to the stream, right? It's like we do all this work to get the flat buffer and then we just like rewrite it to this other buffer. It's like it's really wasteful, and I want to see if we can improve that situation. My sound card is 300 ohms. Is my voice too loud or something, you guys? Are my levels bad? Give me feedback. What am I doing wrong? Okay, great. Undefined is just on the drugs. Yeah, learning Go, you should pick a project that's exciting to you. Yeah, Go is a general purpose language. You can use it for pretty much anything. You know, like, I don't know. What is this? Flat buffers codec? Do we use this? This seems pretty relevant. Seems pretty relevant, but what is it? Hold on. gRPC flat buffers Go. You see this gRPC with codec. You know, I don't think we even use any of this stuff, do we? Flat buffers codec. Huh. I wonder what would happen if we were just like Oh, you know what I think the issue is, though? So how do they define like their service, right? How do they define their service? There's their client. Yeah, see how it takes a flat buffers.builder? I feel like this is some like super next level stuff. Like you can do really efficient stuff with flat buffers if you make your APIs actually consume these flat buffer builder things. But unfortunately, all of our yeah, you know, because like we're essentially sending flat buffers inside of protobufs. That's what's going on here. Man, that's super confusing. Like if I look at what our flow stream thing is here. So if I look at api.proto, this flow stream thing, it takes a producer message, right? And I think this producer message, if I made this thing into a flat buffer producer message, then we'd really be cooking with gas. I feel like maybe that's the project, right? The project is take flow stream and instead of using protobufs for it. Wait, what? How does this even work? I'm so confused. Oh, is it that? It's basically that they define these services in gRPC themselves, where this is some sort of like protobuf gRPC magic integration. That's what this service thing is about. And I guess what they're doing here is that they're implementing these things themselves, I think. Which is very different. Very, very different. And so it might not really be that easy to make this change. It's pretty confusing, honestly. Protobuf gRPC service. Like what is all this? gRPC can use protocol buffers. It's both its interface definition language and as its underlying message interchange format. That is fascinating. The relationship between these things is a little bit opaque to me, but I'm starting to understand it. By default, gRPC uses protocol buffers. But what you're saying is that we could, in theory, like what if I went crazy and I said, you know, like instead of just using this service here, I made like a dissql v2 thing that used flat buffers. I feel like that would be the next level thing that would save like one allocation. And the question is just like, is it worth it? I don't know. I really don't know. I truthfully don't know. The other thing, right. I want to look at one more type of thing. I like looking at the times, the booleans and the decimals. Let's actually get rid of the decimal. We're going to try this one more time. We're just going to look at decimals are like bad for like lots of different reasons. So let's just look at booleans and see what is slow about them, if anything. I got stuck on that other issue. Allocate X, prepare X, execute X, discard rows. Okay, so we're going to hit profile. So interestingly, in this case, it doesn't seem like that was expensive at all, right? So if I search, I guess I can. special type business, right? So I should be looking for batch to arrow. Batch to arrow. I mean, it basically spends no time on this. That's fascinating. It's definitely not intuitive. Definitely not intuitive. So let's say we did... Can we cast any of this information into like a time data type? Show create. Table orders. So can I say select order date time from orders? From the one?
The data bank's too big. I have to narrow down the search. How are you gonna do that?
Can't invalid cast date to time. Wow. What is there like a truncate? Truncate. Order date. Second. Oh, this is something different though, isn't it? How do I make a time? How do I make a time? Does anybody even use time in that data type? Can I cast an integer to time? No. What are the valid casts to time? This is like a very meta kind of, what are the valid casts to time? What a crazy thing to ask. D time. So let's see, cast expr. So we want to be looking for D time. So we can cast a string to a timestamp, but that requires a valid string. Is that it? Maybe these D times are actually just sort of like a random time, like a random data type that nobody actually uses. Kind of feels like that, doesn't it? Or an interval, you can make it into an interval. Okay, so then I could say, then I could certainly figure out a way to do this, right? I could say, now minus O order date. Does this work? Okay, and then I could cast all of this thing to a time, maybe? Does that work? What about like this? There we go. Okay, so let's go ahead and do this. We're gonna say prepare X as. Okay, then I can say execute X. Uh-oh. Well, this isn't good. Okay, let's just kill this. So we just need to do discard rows here. Okay, so let's go ahead and profile this guy. How about that? Who likes profiling? I'm a big fan. It's so fun. Yeah, so CockroachDB definitely not the best fit for a time series database. I definitely would not use Cockroach for a time series use case. It's just not really the right fit. Okay, so here we have, aha! So we finally have something interesting to look at. We have batch to arrow, and we see batch to arrow special type spending a lot of time. I'm just afraid that like we're wasting our time on this data type that like literally nobody uses or cares about ever. It's very possible. Although, wait a minute. I don't actually even see... Oh, this is actually something even different. This is the datum vec canonical type. So this is like the worst case possible thing where we just have a generic type. Which, do I care about this case? I may or may not care about this case. First to apply profiling to a slow piece of code. 600x speed up in a badly implemented stream filtering. Yeah, that is super fun. Super fun. It feels good, right? It's so satisfying. Yeah, so I think... Oh, we do it as an interval. Isn't that interesting? Isn't that interesting? Is that for real? Maybe, did I just make that up? I thought I saw... I think I made that up. Anyway, okay, so yeah, this marshal at stuff. What does this do? It says it actually returns the marshaled representation of data at index I. And yeah, you know what's so interesting is that it actually probably allocates, doesn't it? It actually does allocate. Brats123 and Pezak, thank you guys for the follows. What's up, Mr. Wormhole? What is up? I think what we could do, you guys, we could be doing so much better. We could be doing so much better. We can actually use a scratch buffer and use that in this append thing instead of what we're doing right now. I think, right? Yeah, because we copy. Okay. It's gonna be huge. It's gonna be huge. Oh my lord. Are you guys excited or what? I'm super getting pumped here. So you see how we're doing marshal at, but we could be doing unmarshal too. If we do unmarshal too, we're not gonna have to allocate so much, and that's really the dream. The question is just, how do we know how much data we need? How much space that we need to have in this byte buffer? Oh, wait a minute. Something is feeling wrong. Something is feeling wrong. Unmarshal 2 is not what we're talking about. What we really want is marshal at, but like marshal at into or something like that. I don't think we have a way to do this right now. You know, like, you see how we're passing nil here? We need to be able to pass non-nil. Okay, so here's what we can do. We can say marshal at into, basically. Who uses marshal at? Should we just convert all of the cases where we use marshal at? It's just one case, my friends. Oh my gosh, we could be doing so much better. Let's add a new parameter to this. So it's like, we'll say append to byte. So where is this thing implemented anyway? Datum Beck. Okay, so unmarshal 2, marshal at, we're gonna add a append to byte slice. This is gonna be huge, you guys. Then we can say append to is append to. Just like that. We're gonna have a way better code path. We use Sarama for our CDC implementation. What does marshal mean? So marshal, it means, a synonym for marshal is serialize or pickle, or encode. It's basically taking a binary object of some type and turning it into bytes so that you can send it over the network, you can preserve it, you can write it to disk so that later you can quote unquote unmarshal it back into the object. It's kind of like a way to turn an in-memory object into an on-disk or byte stream object. Yeah. Lots of different words for the same thing, basically. Okay, so this is gonna be big. This is gonna be big. Unmarshal 2. Wait. So yeah, this marshal at, we're gonna have like a little scratch buffer basically. So we can just say like, you know, scratch buff is equal to, we could just say var scratch buff byte like this. And then we could just keep saying Marshall at scratch buff. So this is going to get appended to, and then at the top of the loop, we're just going to reset it. So we're going to say scratch buff is equal to scratch buff of 0. And, or like this rather. And I think that this should save us a lot of time. I think hopefully it'll actually get rid of, well, only a tiny bit of time. No, it'll do all of this. You see all of this time, this gross slice, it's gonna all go away. So this should be like a fairly significant optimization, maybe like 2% faster, right? So like not bad. Let's check it out. So let's check it out. We're gonna go ahead and we can rebuild. Kafka mostly in message broker role for data processing jobs. Yep. So in Cockroach, we use Kafka as one option for how to stream change data outwards. So CDC, or change data capture, is this feature that allows you to listen on a, oh yeah, I had this other project I was working on at the same time. I should stash that. But CDC allows you to listen to changes made on a table and consume them as a stream. So we use this Sorama library to push those changes out to Kafka, if that's the thing that you're trying to push the changes out to. So does that make sense? You know, if you update a row, you can actually see the diff in the row that you updated out onto your Kafka stream. So let's go ahead and say get co-b datamvec, or we'll say arrow batch opt. We'll say git add 1 through so we'll just say work in progress here. We can stash this other stuff. Okay, we'll try again to build. Yeah, Kafka, I mean, it's a complicated project that does a lot of things. But you can think of it, I think thinking of it as a message broker is a pretty good place to start. Seems cool. Okay, so then I think in theory, if I reconnect now, benchmarked any other client than Sorama? I'm not sure. I haven't really looked at the Kafka stuff myself in Cockroach. That'd be an interesting thing to do on stream, actually. I have just never even played with that at all. So it's totally new to me. So let's go ahead and take another preprop. See what we get here. So zooming back into this thing, well, we basically see exactly the same thing, which is a little bit odd. Maybe we didn't do it quite right. Right, I can just use, I need to remember that I can just use this focus machine thing. So sample, refine, focus, and then zoom down and look at, I guess I want to look at this one, view source. Why is this gray? Kind of feels like did I properly like did this not really work? Let's see, SHA-SUM cockroach. And if I say SHA-SUM local one cockroach. Oh, is it just a symlink? It's kind of weird. It almost feels like it didn't, we're not using the right binary, because this stuff being gray is very suspicious. It's like, those things are gray, and those are the things that we just added, you know? It's like, what the heck? It definitely feels... Oh, you know what the problem? I see the problem. That's very, very goofy. We don't return the scratch stuff, so this doesn't make any sense. What we need to do is say... Right, so we have this return append to, so what we need to do is actually say marshaled, blah, 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 append marshaled, and then we need to say scratch buff is equal to marshaled. Or you know what we could even say is just scratch buff. Scratch buff is equal to, like this, var error. Okay, so I think this should solve our problem. We didn't really apply the patch here. Okay, so we'll do our stop. We'll do our put. I'm not sure if we even need to do our put because it's all symlink. We probably don't need to do that at all. And then I'm going to do my SQL local. I'm gonna go back to my profile. And we can make a fresh profile here in a second. Okay, so we'll make our fresh profile, run this a few times, and then see how it looks. Well, this looks bizarre. This looks very suspicious. It looks like I didn't show ranges from table orders. It's probably like it's not... R Redemption, thank you for the host. How does data engineering profits from this? I'm not sure exactly what you mean by that. How come I'm confused what happened with this profile. Let's take another one. This feels very wrong looking, doesn't it? Oh, you know what I think the issue is here? Explain. It's happening on this index. So I bet if I say show ranges from index OOD, it's not split and it's on leaseholder 3, which is me. So what I need to say is alter index OOD scatter. And then, okay, so then we can try again. Okay, so we'll run this. And hopefully we'll get a good profile this time. Okay, this is looking better. So let's go ahead and look at our batch to arrow. And yes, as you can see, we've reduced the allocations. Good for us. We did it, Reddit. Very exciting. Tiny change, but a big impact. No more allocations in the marshaller. Still, I think that there's more that we could be doing though, because like what's very suspicious here, right? We make this scratch buffer, and then all we do is we just go ahead and append right into this binary builder. So it feels like what we should be able to do instead is do this append business using, like we should be able to somehow, yeah, like how do you get this copy to have, how do I get the marshaller to write directly to this slot, right? That's what I really want to do. Is it possible? I'm not really sure if it's possible. It's kind of weird because I know that for the case where we're marshalling bytes, we have some better fast paths. So how does that work? Say we're doing bytes, serialize bytes into arrow. So whatever we do here is some very sketchy stuff. So for the fast ones, we actually just use something called memory.newBufferBytes, and it just takes the bytes. And there's no binary builder business at all. This binary builder kind of feels like we could be doing better here somehow, right? Let's take a look at the documentation online for this. So arrow binary builder. This is like the C++ docs. We want the Go docs. What about these builders though, you know? Where is that stuff at? Fixed size list builder. Okay, so what about, where's this, where's my documentation on this array builder stuff then? I don't understand. I feel like these documentation, not the greatest. Arrow, okay, array, I mean. Binary data, binary builder. Well, I don't think this is really... really telling me much, unfortunately. Arrow Builder is not something we wrote. No, we're just using the Apache Arrow implementation of this stuff, which is, yeah, pretty good. I mean, it's like somebody wrote it, I guess, for the Apache Arrow project to go bindings for Arrow. And we're just kind of shoving this data. We like the columnar data that we use inside of Cockroach is like vaguely Arrow compatible. And so we kind of have to like shunt it around a little bit, mess with it a little bit to get it into proper Arrow format. And it's really cheap and easy for things like integers and bytes, but for other weird types, we spend a lot of time, or like CPU time, doing this stuff, and it seems sort of wasteful.
Computers hooked into over 1,000 data banks throughout the world.
You could populate the whole large flat byte, serialize all datums, and then do the same pointer business as we do for bytes. Yeah, that's true. So basically, we would serialize the datums into our own flat bytes representation. That's kind of smart. Why do we keep both formats? It's a good question. Basically, there's no good answer. Yeah, I think that there was some debate early on about whether we should just use the arrow in memory representation, but we didn't like that. There were certain things that we didn't like about it. Some incompatibilities. And but we also didn't want to write our own serialization format. That felt wrong. So now we're sort of stuck in this in-between world, which feels kind of gross, honestly. Yeah, I don't know. I mean, vaguely compatible for two interacting pieces of software. Yeah, exactly. On the other hand, like maybe I shouldn't even be bothering with this because, of course, we're expecting to get rid of this over time. And maybe what I ought to be, I mean, but I think we do exactly the same things over here. Anytime we use a binary builder, we're doing bad things. These binary builders are really inefficient, it seems like. Yeah, I feel like it's this. Wait, now I'm confused. Where did this binary, where did it go? Oh, this is in arrow to batch. In batch to arrow, we have this binary builder business. Binary builder business, the triple B's of doom. Yeah, it's like we use this thing all over the place. In all of the special types, we're using binary builder. And I posit that binary builder is terrible and it needs to be deleted. And so we really should be able to do this same technique for all of these, right? We really should. We really should. All of these things have basically the same problem. We have several to-dos in place, yes, indeed. Yes, indeed. The serialization is quite inefficient. Yeah, no, I think we know it. We know it. For the benefit of the folks on the stream, though. I actually, my eyes skipped right past these to-dos, didn't it? Yeah, so I don't know, maybe we can just sort of do better. It's just like these types, like who uses these types? Which are the ones that we should concentrate on? You know?
Everybody knows that relational databases don't scale because
Grazio, thank you so much for the 2 months of Prime. Appreciate it.
and write to disk.
So here's a question. Well, this decimal business is like totally. I'm gonna ignore decimals. We know that they're tricky. It's just all of these things really they should take. Really, we should have access to the inside of the binary builder. That's the key. That is the key here. And I guess Yahor's suggestion to use our flat bytes representation seems relatively reasonable. But then again, there's all this confusing stuff here. Like, look at this. Look at this. What is going on with this? Like oh, I see. It's really the same. Like, really, we want to have a giant buffer with offsets, right? Yeah, what if we, okay. What if we said, okay, call data.bytes. What does this thing look like? It's got data, it's got offsets. Are we allowed to peek into this data? Probably not, right? That's basically the trouble here is that we're not allowed to peek in to any of these areas. That's really a challenge, actually. It's really a challenge. No peeking. No peeking. This append val has exactly the same problem that the binary builder has, which is that if you were somebody who wanted to marshal to a spot, you would have to first marshal to a scratch space and then copy again. You know, it's intense. It's intense. Easy win for Datembeck. Started go, why can't you pass a pointer to another function? You can pass functions around, right? That should be fine. And I think pointers to them should work too, right? I think so. I think that should work. What's up, Deep LSD? How's it going? Let's take an example. Well, we could just sort of construct it by hand. We'll say like var, we'll say var buff byte, and we'll say var offsets int. And are they supposed to be ints or are they supposed to be something else? Serialize bytes into arrow. It takes offsets, which is they're pointers to byte slices. That's a little confusing. Where do we get these? Oh, I see. So that's writing out. Okay, never mind. So it actually takes a call data.bytes, and then it calls 2 arrow serialization format on it. And inside of this thing, can I construct a call data.bytes with data and offsets? Is there a way to do that? Probably not, right? But I could. We could just add a constructor for that, no problem. Just to reuse this function here. So otherwise it's a little bit complicated, I guess. I guess I could restructure things. You know, I guess I could pass in, instead of passing in call data.bytes to this, I could be passing values in at 32 offsets. Let's do that. That seems better. Okay, so we'll do in 32, we're gonna say, right. Yeah, so for this case, do we have to be tricky? I think we have to say offsets equals append. I guess we can say, let's see, var cur offset in 32. I guess offsets is equal to append offsets cur offset. I think we add a same valued offset, right? If there's a null, I think that's right. So then down here, I just basically say buff is equal to datum.marshal at buff of I. And then I guess I've got to figure out the length, right? So old len is equal to lang of buff. And then basically I say offsets equals append offsets. I guess I actually say cur offset plus equals len of buff minus old len. And then I can say offsets equals append offsets cur offset, something like this. I guess I can int 32ify this thing. Seems fine. What's wrong with this though? Old len needs to be an int 32 as well. Oh, I guess I should int 32ify this entire thing. Oh yeah. You're totally right. This is pointless. So we just say offsets equals append offset len of int 32 len of buff, like this. Okay. So then we can get rid of this binary builder stuff. And then I guess what we do is we can restructure our other function to become improved. Where was it? Serialize bytes into arrow. So this thing is now going to take, it's going to take, It's going to be confusing to have, I guess we can call this like out offsets. And it'll also take in byte data in 32 offsets like this. I think this is what we want. Something like this anyway. We get rid of this here. Wait, what did I do? Oh, return values. That's interesting. So I guess this, let's actually go to the call sites here. So I think what we'll say is spec.bytes.to arrow serialization format of n. And this is going to give us values offsets. And we're going to pass in our values, our offsets, and we're going to, this has to be like, this is annoying. Should I just rename this whole thing out offsets or something? Just rename this out offsets. Or we'll call it offset pointers or something. I'm confused by this. What is this weird thing? Yeah. It's very, very suspicious, this out offset stuff, but that's okay. So we'll just rename this to be out offsets. And this is going to be offset, so values offsets is equal to vec.bytes.to arrow serialization format of n. But it's like worse than that too, because we are editing. I'm confused why we're doing this. Oh, we're turning. We're turning an int 32 slice into a byte slice. I see. Yeah, so maybe we can call this like offsets bytes. How about that? The very other confusing thing is that I think we can now get rid of this, and this doesn't have any return parameters anymore. basically like this, I think. Okay. So really this needs to be now changed to be called like update or like unsafe cast offsets array. And then we can get rid of batch length and data. Okay, so this is getting a little bit more refined. Maybe. Just a little bit of a refactoring here. Okay, so then we change like this. We say var offsets int32. All right. Okay, so then coming back down to where we were gonna do this other stuff, what we do is we say, we've got our offsets array here. And then what we do is we say, so batch to arrow special type, when we actually return this, we continue to do weird stuff with it or no? We say data arrow is equal to, if data is not equal to nil, then we set it directly. So I almost feel like what we want to do is get rid of this special type business and just start making a main switch statement for it. Like, I don't really know. We're going to be updating these things, and that's kind of the point, right? I think so. Okay, so let's go ahead and pull out this whole thing, at least for now. Yeah, exactly. So we'll put a case down here. And so then what we do is we basically say, we need to be setting offsets and values, right? So in this case, this buff should actually now be called values. Well, let's just get rid of buff then and replace it with values. I think that's fine, right? I think that's fine. And then we're updating our offsets array. And then what we do is we say unsafe cast offsets, and then we pass in our out offsets, which is called offsets bytes. You know, we ought to also call the other one offsets bytes and not out offsets, I'd say. Let's fix that real quick. Offsets bytes. So let's change this to say unsafe returns unsafe casts the input offsets array into the data. Sorry. Unsafe casts the input offsets bytes array to point at the data inside of the int32 offsets array. And maybe what we ought to do, first of all, why are we saying array? We should really be saying slice. Let's change this guy to also say offsets int32. All right. So then I think we're like kind of good to go, right? We do our unsafe cast, this thing gets edited, values are set, and then I think we're good, right? Well, is that the only change that we have to make? Because now I think the format's actually the same in the end. We don't have to change anything on the deserialization side, which we can check out over here. What we do down here is we do our null bitmap stuff. I might need to look at that. Do I need to fix anything about this null bitmap? And Marshall 2. I mean, that seems fine. Let me just, did I screw up the null stuff? Nope, I've got an append null. I've got an append cur offset. It didn't update cur offset though. So I don't need cur offset at all. I think I can just say len values in 32 of len values. Num buffers. Why don't we just run the test? Make test, package equals package, call seriality. Okay, so what we're getting is a failure to reconvert. We're getting a failure to reconvert back from arrow back to the batch format. I'm a little surprised that I need to change the deserialization because I thought that I basically, this change actually is doing the identical thing. Thought it was doing the identical thing, but maybe I'm wrong. Oh yeah, this is totally broken, isn't it? We need to fix the nulls. We need to fix the nulls. The nulls get fixed automatically though. Arrow bitmap equals null dot null bitmap. This isn't gonna change anything, I don't think, because I think that we're just gonna ignore that binary builder altogether. Yeah, so okay, let's go ahead and change the deserialization stuff. What's up? Illiger? Iltiger? Illiger? So in my deserialization, what do we actually do? We say new binary data, set null bitmap, do some stuff over here. And where is this actual panic coming from? It's coming from value bytes. Value bytes. It's right here. So it's kind of just like the most basic thing that we've got wrong, but that's good. I mean, it seems like it should be easy to fix then. Kind of seems like we've got a malformed kind of input here somehow. So let's go back up here and take a look. So for every iteration, oh, I don't think we have a, do we not have a 0th offset? Is there some problem with that? Do we need a 0th offset? Something like that? Is it actually that? Yeah, I think there's like an off by 1 problem. I think we need like this basically. I think we just had a little bit of an off by 1 problem. And we need to put, nope, it's still the same issue. So for each element, we append the current offset, which is the length. We add more data to the values. And then on the next one, we will put the next offset. So that feels mostly fun. You can also pre-allocate offsets to be abandoned. Yeah, that's true. Do you actually, is the offsets array supposed to always contain 0? That doesn't feel right. Offsets make int 32 len bec dot, or what is our n here? We have n already, and +1. I see. So at the end, we do in fact need to say offsets equals append offsets len of data. Is that right? Is that right? Good point. Okay. What about now? Moment of truth. Slightly better. Test record batch round trip through bytes. So now we're getting a failure on line 173. Because my data header is nil. If values is nil, so values should not be nil, right? Values is not nil. So why are we even there? Is the question. I guess if we have a 0 length, array, is this about a 0 length array? Test record batch round trip through. Ba-ba-dum-bum. I feel like this is about a 0 length situation. And I think what we need to do here is say if n is equal to 0. Well, this doesn't feel quite right. Wait a minute, what line was that on again? It was on values. I mean, this could be either, I suppose. Or is it this data header thing that sort of... What is the deal with this data header business? Where does this get... Oh, this is interesting. But we don't seem to use this at all for the non-bytes types, or for the bytes type, so I think we can probably safely ignore this thing. I think the key is that we just have to make this non-nil if it's size 0. I think that's probably right. So we'll say if n is equal to 0, values is equal to... I mean, does this even do anything? I'm kind of confused by this, but that's okay. Still the same problem. That is fascinating. So why don't we just go ahead and say, yeah, so this should never be happening, right? This should never be happening. Why would this be nil? Why would this be nil? Well, we can just use the debugger. We can use the debugger for sure. So let's go ahead and run, what is it called? Test record batch through bytes. Just use the old debugger. Look, it's so sunny. This is a very chiaroscuro kind of thing on my face. Check this out. Is he good or is he evil?
The data bank's too big. I have to narrow down the search. How are you going to do that? By guessing.
Suboptimal, thanks for the follow. Okay, so what is the type that we're looking at right now? We're looking at OID family. Okay. And what's our N? Our N is 220. And are we going to enter this? We skip this thing. Okay, so I guess we need to breakpoint here then. Okay, so now we've got N633. Our type is now float, so this should probably be fine too. Type is float again, type is float again. Bit. I think this one maybe will fail then. Our N is 11. Yeah, okay, so we failed at that moment. And what exactly happened? Values must be null for some reason. But why? Oh, it's because I... Oh no, never mind. Let's go. I guess we could go ahead and breakpoint inside of this thing and try again. Okay, so our, let's see. Our type is now OID again. I don't think that we failed on this one before. Oh, if they're all nulls. Is the problem is if they're all nulls? Is that the issue? I guess what we should do is say, we can just say values equals, we could just unconditionally pre-size values to be like n, basically, because it's going to be at least n. Unless it's all null, in which case, I don't know, I guess we'll waste some allocation. Well, that should be fine. I guess we could say, yeah, so if n bytes is equal to n, if n is equal to 0, n bytes is equal to 1. Well, no, we don't need to do this. We can just literally say this, and that should be fine. It'll never be null. We at least say make, even if it's 0. Okay, so something good happened, but then we got some other problems. Some improvements. It feels like we really broke stuff, though, which is a little bit surprising. I was really expecting this would mostly work. N to 0, n? N to, oh, I see. Absolutely true. Yay. All right, we did it. Great job, team. So the purpose of this was that now if we come back to our profiler, we'll remember that we saw some sketchy stuff in there, such as the fact that we had to do marshal at, and then we had to do append. Look at that, so expensive. All of this stuff together is very expensive. I think now everything should be much, much cheaper, hopefully. So we'll do roachprod stop local. Roachprod start local. Wait, we didn't do make build. We have to do make build. Very important step. Never forget to make build when you're changing the code. Important rule of thumb. Okay, so now if we try our tests again, so we're gonna prepare X. First use tpch, prepare X. Now if we run execute X discard rows, we'd expect that this will be a little bit faster. So far it looks about exactly the same speed. What was the absolute time that we were spending before on this thing? It was 1.333, and now we're spending 1.270. That's a pretty big difference. Not too shabby. But let's go ahead and run a profile just to see what we can see inside of the profiler. Hit this. Run this a couple times. Jump back to the profile and see what we see. Dang it. Okay, so we see this problem again where we have to scatter the index until it's on the node that we are profiling. I'm looking at node 1. Okay, so now I think we should be able to see this. If we run the profile, I think I would be too slow this time. I'll try again. Okay. Still too slow. I didn't have it in my buffer. This is like the most janky form of profiling. The up arrow profiling method. What's up, the Rob White? How's it going? Okay, so here we finally see our good flame graph. And if we zoom into batch to arrow, what we see is that we're now spending our time all in Marshall at, which is much better, I think. This is a little suspicious that we've got all this gross, like, well, is it? I guess it's not that suspicious. I suppose what we could do is a better pre-sizing, right? Like the fact that we're guessing that values is size n feels pretty wrong. This is probably more like n times x. Like, don't we have some estimated size, by the way, for these datum vecs? There's got to be some sort of estimated size. The estimate is oh, this is an exact. I'm not sure if we should be able to should we do better here, or should we just, estimate batch size bytes. Estimate batch size bytes. Let's say we are a datum. I see, so we kind of guess here. Well, I suppose we might as well use this exact same thing. So we can use datum type size for this to make a slightly better estimate. Tree.datum type size of tip. This is going to return two things, so we'll have to capture. So yeah. So make a very, very rough estimate of the size of the number of bytes we'll have to allocate for the datums in this vector. This will likely be an undercount, but the estimate is better than nothing. Okay, so if we do that, I'm sure that this is pretty much going to be the same speed, about 1.28 or 1.3-ish, whatever. But just curious if it's going to change the profile at all, so we'll try again. This time we'll remember to scatter the index so that it's living on the node that we're profiling, which is node number 1. So we'll stop our nodes. We'll start our nodes. Use tbch, compare x, show ranges. Okay, perfect. So now if we can do execute x and run our profile, and we should maybe see something different, but I'm guessing it'll be about the same, actually, just because I don't think it's actually maybe, yeah, it's about the same speed. Be marginally slower, but I think it's probably just noise. It's a very noisy thing. I'm measuring these like tenths of a second that really probably are not meant to be measured. So we can zoom in to our batch to arrow. And we see, no, I mean, we don't see any allocations left over in this profile. So I do think that improved things a slight bit, which is great. We'll take those. We take those. So cool. That's pretty satisfying. It's pretty satisfying. There's a separate question about why this is using table reader. Should not be using table reader, ideally, but I feel like there's something. Uh-oh. We've got the old camera temperature is high problem. Hold on a second. We're gonna need to figure out a solution for the high temperature camera issue when it becomes summer. It's not gonna work. For now, the solution is reboot the camera with the fan on. Because of the cast. Yeah, the thing about the cast, though, is that, like, theoretically, we should be able to use the C-fetcher, which we think is more performant, right? And then run the cast. Well, maybe, yeah, maybe you're right. I was going to say you could, like, use default. So what are we doing here? There's some sort of it's also got this now cast. There's all sorts of weird crap going on here. I feel like it's maybe terrible. Aster, thank you for the follow. Unhandled cast into interval. Yeah, I guess it's like we should be able to do that by like casting the things to datums or whatever. Like isn't there some path that we use for that somehow, sometimes? Maybe not. Maybe you'd have to send it through the whole columnarizer materializer thing, which would be sad. I don't know. I'm sure you know. Anyway, what else should we look at? I wonder if we should look at the inverse now. That could be kind of interesting. So instead of profiling this node number 1, why don't we profile this node number 3? Or better yet, we can just connect to node number 1. And then profile it again, but have the data be sent in the opposite direction. So we're going to send it from node number 3 to node number 2. So let's scatter OD again, use TPCH. Show ranges from index. Yeah, this will be good. So then we're gonna do our prepare. We're gonna do our execute, but first we're gonna make a new profile here. And so this is gonna be profiling the opposite, which is deserializing the arrow data back into batches. See what is expensive or not expensive about that. Should be interesting. Hey Nami, you didn't miss too much. We found a little bit, some performance optimizations, and we made them. I think they improved things a little bit. We were optimizing the path where we serialize a certain data types to this arrow format. We saved a couple of allocations and saved a couple of little copies and stuff like that. Pretty minor, but you know, maybe like 2% or something like that. Yeah, I'm using WSL too. Thank you for the follow, Sosan123. So in this case, here's the opposite, right? We were talking about outboxes, and here's the inbox. And this is kind of the thing that we should be looking at. Here we do a receive, and then we do a arrow to batch, an unmarshal kind of situation. So the opposite direction. Question is, can we do better? Can we do better? Sure, we can do better, maybe. Let's take a look at this inbox code. Stream.receive. I'm sure we can't really do much better in receive, but I'm actually just kind of curious what it does. Docker container and WSL turned at the same time, and because of cache, both are contained combined using 6 GB of RAM. It seems normal. I don't know. Seems fine. So we allocate a little producer message, which is slightly sad, but who cares? And then we call receive. And ultimately that does two things. One is the receive and decompress, which is expensive. It does receive message, and this probably allocates a big slice, right? Yeah. To-do Brad fits. Garbage. Reuse both buffer after proto decoding instead. Yes. To-do Brad fits. Yes. Brad fits, where are you at? Help me with this to-do. I agree with it. Yeah, I would say it's at most 2%, and it's basically if there's a distributed query that's sending data that doesn't have a built-in, well, yeah, it's kind of like for a few data types. If you're sending a lot of it over the network, you're saving maybe some percent. But I think, I mean, that's the thing about these parts of the queries is that like they always sort of quote unquote hammer the code path, right? Because if it's a big scan, like an OLAP query, then whatever you're doing, it's going to hammer the code path. I feel like that's what makes it so satisfying to kind of profile and optimize the database, is that a lot of these code paths get used just a ton because each query causes that part of the code to run like a bajillion times if you're looking at a bajillion rows. It's sort of like a one-to-one row to call thing. Or, I mean, there's the vectorized batching stuff, which reduces that somewhat, but you know, even still, all the rows go through all the code sometimes, so it can be really fruitful to optimize that stuff. The debug shows how heavy the queries are. Kind of, yeah, it's kind of showing how much CPU the database is spending in different parts of the code. Yeah, this thing is built in, but we didn't write it. It's something called pprof. We've just embedded pprof into Cockroach, so you can use it. Anyway, so it looks like we're probably not going to be able to do anything about this receive. It is sort of sad that we're doing all of these allocations, but what are you going to do? And the other thing that we're doing is after receive and decompress, we unmarshal, right? And in unmarshal, we call unmarshal again, which calls into, well, I guess for this we have to go back into our data.pb.go or something. Exec infra pb. Data.go. Unmarshal. Producer message. Unmarshal. And so this does a bunch of stuff, and somewhere I think it allocates as well, unfortunately.
I have to narrow down the search. How are you going to do that? By guessing.
Producer data.unmarshal. So in unmarshal, where are we doing these allocations exactly? Aha! Raw bytes is equal to append raw bytes data. Well, nothing we can do about that. Unless there is something we can do about it. Where do we like allocate the initial producer data is a question. Producer message. Where do we allocate the producer data? Oh, well, we just constructed a new one. So there's something we can do about it. I do feel, to be honest, I feel like some of this stuff is just a little bit inefficient. It's just a little bit inefficient, unfortunately. You'd really like to be able to reuse these things, reuse some buffers, but we can't. But that's okay. Wow, it's really bright. It's right in my eyes. This is like the golden hour for me. What do you guys think? Better like this? So bright. Hello, and welcome to my YouTube channel. I am half bright and half dark. pprof is more of a Go library than a CockroachDB thing. Yeah, exactly. It's from Google. What do you spend on decompression? We use snappy compression for stuff, but I actually don't think we use compression on the wire. I could be crazy, but I actually don't think we really use that. Let me check. Let me check. I don't think we use it for this particular thing here. How would I check that? It seems like it's pretty dynamic. Like how do we choose which compressor that we're using here? ss.decomp. So what is this thing set to? Encoding.getCompressor. Registered compressor. Wow, this is fairly complicated. Register compressor. Snappy register compressor. So maybe we use snappy decoding, snappy compression. Yeah, I don't know. Hey, Marilia. No, that was just kind of bad luck on your part there. I was just joking about the sunlight here. Oh, I also forgot to switch it back to my desktop. But anyway, I don't think that there's too much we can do about this, unfortunately. But maybe we can still do something about this arrow to batch business. So let's go take a look. Let's go take a look. So we're in this case called datum vec canonical type family. And I mean, I don't think we actually do all that much here, honestly. We don't do any unnecessary allocations besides the ones that the datum stuff does. This unmarshaled 2 thing is expensive, but we always knew that this would be expensive just because this is the sad truth about datums, which is the row by row encoding that we used to use, which is that they have one box or one allocation per value. So if you have 1,000 rows, that's 1,000 allocations. So there's really nothing we can do about this besides continuing the good fight of getting rid of these types that do not have a specialized encoding or representation in the vectorized engine. So that's kind of what we did last time. We added the JSON. And so we'll have to just continue down this path of adding more and more to the ones that don't need datum vec, right? So you have this is basically the list of types that we support in vectorized. You got your Booleans, your bytes, your strings, your UUIDs, your decimals, your JSON, int, date, float, timestamp, TZ, timestamp, and interval. And so other things than that we're missing for. You turned the sun. Thank you. Appreciate it. Yes. It's always a good look to have sun on your skin. Yeah, so I don't know. Maybe there's really nothing else that we can do for this particular one. You know what we could do, though, is we could go back and probably do the same optimization that we just did for the rest of these quote-unquote special types, right? Thanks for the follows, Mushu, Mitzi, Raon, and E. Albert. Appreciate all of you. Right, so we have this bool family stuff, we have this decimal family stuff, and I think for this decimal family stuff, there's really not much we can do because I don't think... Essentially, the problem with things that give you a string back is that there's no way to like teach them to like marshal to... Well... Oh, actually, I take it all back. We do have what we need here. What we need to do is use this append thing instead of string, and then I think we should be good. That actually could be really easy for us to do. Yeah, why don't we take a look at this decimal stuff? I think we could make a pretty fast improvement for this one as well. So we're gonna lift up our decimal case back over here like we did before. And we're gonna basically do the same thing we did over here for the datum case. We're gonna make an offsets array. Instead of making a datums array though, we're gonna be looking at our vec.decimals. I guess it's kind of like this. And then we're going to, for each of the decimals, we don't need to look at nils. I think we can just, probably want to look at this just to continue, but we don't need to actually do anything. And then this marshalling business, this is where the magic happens, is we get to say, I guess we need to still make our values array here. Yeah, so I don't know what the average, let's see, estimated size. Trying to remember what the way to estimate the size of a decimal would be here. In estimate batch size bytes, we say if it's a decimal, we just say it's 50. Okay, sure, it's 50. Seems legit. It feels wrong, but that's okay. We should probably pull out a constant for this though, right? We don't know exactly how big a decimal will... Well, 50 feels a little big. Serialize 2. Let's estimate. 50 is also not like a nice power of 2, so I don't like it. 16 bytes. ZSTD says 40% more throughput, still better than Snappy. Oh, that's cool. Yeah, I've heard about this ZSTD business. We probably ought to look into it. Okay, so then at every point we're going to say decimals of I, and then instead of saying marshal text, what we get to do here is that we're going to say, append. We're going to pass in our values. And we're going to pass in our format G, which I don't know exactly what this G business means, but yeah. It's a little bit suspicious, in fact, that it's leaking out of this package, but that is just life. I don't know if there's too much we can really do about it. So C apd.decimal.string. We use the G format string to indicate. What are we indicating here? Like E for large exponents? Well, whatever. We use the G format string for serialization. Okay. So here we're going to say values. Error is equal to, we'll say var error. Rob White, any advice on how to get started understanding the Cockroach codebase? It's a good question. It's a very big code base, and it kind of depends on what you want to get started with. There's a couple of things. We have something called Good First Issue, which is a more or less sometimes updated version of some issues that are good for external contributors to look at. I think for beginners, I really like to recommend looking at built-in function implementations, which are a really, really straightforward way of get started. So if you go, this is the wrong package actually. If you look at this file called builtins.go in package SQL sem built-ins, in fact, there's a bunch of files in here that are pretty similar. You can basically see where we've implemented sort of built-in scalar functions in SQL. So for example, like the concat function is implemented here. And it's really, really straightforward and easy to get started with. You sort of fill out some structs with some properties, depending, sort of explaining like what the built-in function does, whether it accepts nulls or not, what the types are, what the return type is. And you can make a little Go program, a Go function that gets invoked when you call that built-in in SQL. So it's really, really satisfying and easy to get started. If you just make a fake built-in that does whatever you want, you can add it into here, you can recompile, and all of a sudden you can say, select my function of 3 or something in SQL, and it'll actually do, it'll run your code. So I like recommending that for just starting to just get started with the code base. It's maybe more. It's a little bit like in the middle of nowhere in a sense. Like it doesn't teach you that much about how the database works, but at least it's something to get you started playing with the code base at all. So I don't know. That's my spiel there, Rob. I'm not sure if that's helpful, but yeah. Okay, so back to this thing. This thing doesn't actually seem to return any errors, which is convenient. So forget this var error business. We'll just say values equals decimals that append values. And then at the end, we grab our offsets like we did last time. And this is almost feeling like we ought to extract something, because this exact same pattern is now used in 2 places, right? It's like, get your list of things, create your offsets, create your values, loop over the stuff, skip nulls. And then the only thing that's changing is like this guy here. So it's feeling like we could do some extraction of logic here, but I think I'm going to skip it for now. Peter says, do you use Vim shortcuts in Golang? Yes, I do. I use the idea Vim plugin to make sure that we can use Vim. I wouldn't be able to live without the Vim bindings. I'm just used to them at this point. Okay, so let's go ahead and save this and see if we see any difference. We probably should make sure if we need to make any changes to deserialization. I don't think we do, but there's always a chance. What we should probably do is just let's run make test on the CRD package to make sure that we didn't break anything. Looks like we didn't, which is really nifty. So we'll run make build again. Okay, so let's go ahead and run. Well, let's see. We'll stop our local cluster. We'll start our local cluster up again. We're going to connect to node 3. We'll go ahead and show ranges from our index. We'll use tbch first. We'll show ranges. We want to make this is going to be on node 3, I think. Wait, no, we want this to be on node 1. So we're going to scatter until we get it onto node 1. Okay, so now we can prepare. Now we're going to do a different query this time. What we're going to do is we're going to cast some float. Let's see, show create orders. what we're going to do is we're going to cast some float into a decimal and then cause that to be serialized over the network. So we'll say prepare X as select O total price decimal from orders. Now we're going to run it. So it takes about a little over a second. And if we go back to our profiler now, we can prepare to create a new profile. And click the profile and then run this a couple times. See if we can get some data. Weirdly, it got quite a bit faster. I wonder if something warmed up. I don't know what the deal is with that, but that is okay. And then coming back to our profile, what do we see is we see a bunch of time spent in the reading, here's the time spent in the casting, and then here is our serialization. And it basically looks like what we've got going on here is spending most of our time in append, which is great. This is sort of what we wanted. We don't have any of those allocations any longer. I think this is good. I'm sure that there's actually a micro benchmark that we could have been running for the decimals in particular that I bet it would see some significant improvements actually. But this is good, I think. I'm wondering what this make slice is about. I guess it's these ones, right? Offsets and decimals, or offsets and values rather. But that's okay. There's nothing we can really do about that. Not such a big deal. Yeah, I'm actually kind of curious. So if I were to run make bench, what happened to my make bench? Did I lose it in my history? You know what's annoying, you guys? If you run, I have this problem all the time. You run some commands outside of a screen session. Then you're like, I really wish I was in a screen session. And then you enter the screen session. Those commands that you used to run outside of the screen session, not included in your history. Very frustrating. You have to reconstruct them. But here it is, benchmark arrow batch converter. Benchmark arrow batch converter. So roach prod, stop local. So we'll say make bench, benches equals benchmark arrow batch. Actually, wait, let's just go ahead and take a look at which of the available data types. Benchmark arrow batch converter decimal. Okay. Arrow batch converter slash, yeah, I don't know what the format is, so we'll find out. Package equals package call CRD. So it looks like it's going to be like this. We'll put decimal, and we'll say null fraction is equal to 0. And so what we can actually do is we can compare before and after this PR and see what the difference is. I guess, hold on. Null fraction is equal to 0.00. So this should run 2, arrow to batch and batch to arrow. Very cool. So why don't we go ahead and add this to our work in progress commit. And then what we can do is actually something neat. We can run this special script. So script bench. If only I remembered how to do it. I think it's like this. So we're going to say benches is equal to, I guess it's basically we just copy this whole thing. And we say, uh-oh. The heck? There's this like super sketchy shortcut in Windows that like automatically opens a window to office.com or something, which like I don't know what it is and how to disable it, but it's like really irritating. It's like there's a couple of annoying things about the Windows thing, and that's definitely one of them. So we're gonna say script bench, and then we need to say old branch is gonna be arrow batch opt tilde. So we can go ahead and let this run, and hopefully we'll see a difference. I always say in a screen TMOC session, Restart ritual is to open a tmux whenever I start working. Yeah, I usually do that too, but it's if you forget, you know, it's so frustrating. If you forget, then you get into trouble. Tmux resurrect. Yeah, I never switched to tmux. People love tmux. I'm just just used to screen that I never got into tmux for whatever reason. Screen has weird keybinds UI. I feel like I'm used to the... Oh yeah, look at this. This is like a fat 40% reduction in time per op and 60% reduction in allocations. Truly the dream. Yeah, screen does have similar shortcuts. It's just, instead of Control B, it's Control A. And that's like a bunch of stuff that's the same. Here's the bindings. I think it's basically the same program. I don't really know why somebody invented tmux, to be honest, because screen is like the same thing. I don't know. I guess it's just older. Did you hear that there's like a new screen or tmux thing in Rust now? Rust screen, Rust tmux. No. Rust terminal multiplexer. Zellage. You see this? Zellage? How do you pronounce this exactly? Zellage. Oh, it's is it like IntelliJ but Zellage? Anyway. Basically seems like yet another one of these things, but who knows? The shortcut is Win, Control, Alt, Shift. What the heck? What kind of ridiculous shortcut is that? Win, Control. Wait. Win, Control, Alt, Shift. What the heck? What? Who came up with this? Literally, who came up with this? Why would this be a feature of Windows? That's disgusting. It makes me so mad. Thank you for the pointer, Easy Light. I will definitely do this after the stream. The office key. Oh, so they added like a special keyboard, but it actually just like types a bunch of modifiers. Ugh, that's so janky. So this is like a pretty good result though, you guys. I think this is quite a good time of reduction. So let's go ahead and add this to our commit message so we can look at it later. We'll fix the name of this commit a little bit later, but let's just preserve the these benchmark results because they're pretty nice. Okay, so is there anything to look at in the deserialization of decimals? This serialization is quite inefficient. Improve it. I don't think it's that inefficient. I think this is just life. This is just what the decimals are like. It's not too much we can really do about it. You know what we will do though? There's one more thing that we'll quickly do here, which is get rid of yet another one of these special types. We can do exactly the same thing with the interval family stuff that we did before. We're just going to do this for all of them. And then I think it's actually going to be a nice improvement. I think it's going to be a nice improvement. So let's grab this. What happened? Deleted something wrong. So if we have an interval, okay, so in this case, we run this in code. And then instead of putting uint64 into this scratch, what we do is we say values. And then the thing is here that we have to be a little bit more careful. Actually, we don't. We know exactly the size of this whole thing. This is amazing. So we can make values exactly the right size here. We make it exactly the right size, irrespective of nulls. The nulls don't really matter here, do they? Oh, I think they do. I think they do. I think what we need to do here is we need to say values of... I think what we'll say is we'll say cur val u is equal to how about this? How about this? We'll just say values equals append. No, it's not going to be quite right either. I think we just want what we say. We're going to say cur idx is equal to 0. Say var cur idx. Var, it's not cur idx, it's like cur interval, cur non-null interval int. And we say cur non-null interval plus plus down at the bottom here. And then what we say is we say cur slice is equal to values of. So hold on, we're gonna pull this out and say interval size. What's up, graph miner? We're gonna say the cur slice is equal to values of interval size times cur non-null interval, and we're gonna go until. Well, we don't even need to do that. We can just do it like this. What's up, Sora? How's it going? Look at that cute little Linkus. Oh. That's a good emote. Okay, so then here we're going to say cur slice, cur slice, cur slice, and then we can get rid of this. And then down here we just do our unsafe cast offsets array, offsets bytes. And then I think we should be good with the intervals. And in fact, let's see if that's the case. We're going to run our tests. What's up, WizX? I think you are missing a space. You have an extra space in between the exclamation point and the keyboard there. That's why it's not working. So slice bounds out of range with capacity 0. What happened? What happened? Well, I'm not using my offsets. That's the problem. Same problem though. Okay. Must have been something that I did wrong here. Out of range 8 with capacity 0. Oh, I need to say interval size times n. And this needs to change to remove the n. Okay, I think that should fix the problem. Okay, so some improvement. However, we incorrectly serialized the intervals, so that's not good. That's not good. So what are we doing wrong here? What are we doing wrong? Got our offset set up right. Got our interval size. Guess we could cap off our cur slice just to make sure we're not doing something wrong. We could say interval size times, we'll say interval size plus 1 times cur. No, we say, so we're making a slice from the cur non-null interval to the one after that. So we have to add 1 to that number. So we'll say interval size times cur non-null interval plus 1. I don't think that that'll fix the issue, but it's good to try. Okay, it's the same problem. Interval mismatch at index 0. It's suspicious. It's a little bit suspicious. This is Windows terminal preview. I'm using Windows. God darn it. Believe it or not, it's actually Windows, my dude. Imagine that. Linux on Windows. Whoever thought that they would see the day? I certainly never thought it. I never thought it. But it works pretty well. I'm happy with it. I'm confused about what I possibly could be doing wrong here. Right, we put nanos, months, days. We didn't change this at all. What did we change, if anything? Doesn't feel like we changed anything, really. Windows are finally getting the fact that open source is a win-win for both sides. Yeah, exactly. You saw that they made this big announcement too. It was like WSL2 GUI. This thing is super crazy. Look at this. The initial preview of GUI app support is now available for WSL. So this is going to be super sweet. I don't think I want to update my Windows installation to like the insider build or whatever, but basically what this does is it makes it so that you don't have to run this like X server thing. Like I'm running this X410 business, which is like a Windows X server. But I think the point with this is that it allows you to run the Linux GUI apps in the native Windows Chrome or something like that. Like I don't really know how it works, but it seems pretty sweet and it's nicely integrated and it should be really cool. Thinking about getting a Mac Mini for work. 5 to 7 watts for the Mac Mini is much cheaper than 200 watts for the gaming PC. Yeah. That is a good point, Easy Light. All those watts, they do add up, you know? They certainly add up. Oh, you know, do I need to like size it down, size this values things down at the end or something like that? Is that the problem? What if I say capacity 0, then I'm going to say values equals append values. Then I just make an empty byte slice or something. I don't think this is going to do anything, but reverse wine. Windows shipping their own X11 server. Yeah, that's probably true, actually. The amount of freedom Linux gives must be a standard in OSs. 30 plus cents per kilowatt hour. So it's still the same issue, unfortunately. What did I do wrong? I'm so confused. It really felt like I did an equivalent change here. Let's get rid of this because we know that that's not really helping anything, right? At the end, we should probably say values is equal to values to n times cur non-null interval. Not n times, we'll say interval size times cur non-null interval. This is definitely not going to fix it either, but let's just run that. Oh, I see the problem. Oh, this is such a dumb problem to have. Okay, so the issue here is actually that we do need to do something a little bit smarter here, since we're saying when we append our offsets, this is gonna be, yeah, this is wrong. Like, because values is always the same length. So what we need to say is the offset is actually cur non-null interval times interval size again. Type int, so we need to just int 32ify this thing. And then same down here, we just need to say, well, this is actually correct. So we can, let's try this now. Maybe this will fix it. This might, yay, okay. So that fixed the problem. So now we can run our benchmarks and we can use interval. So we don't have a benchmark for that. So let's quickly add a benchmark for this. What's this about? 211. The number of bytes we're converting on one iteration of the benchmark for the corresponding type and types. What the heck? What is this exactly? This is basically saying the size of the data type, I guess. I think it's also 3 times 8. You can do unsafe things in Go, but I don't understand how that interacts with the GC. Pointer arithmetic seems incompatible with GC. You can do these things, but you have to be really careful about it. There's certain semantics. So you can read about, there's this thing called unsafe pointer Go. And so there's a lot of rules to these things that you can use. You see there are these 3 rules here. Pointer allows a program to defeat the type system and read and write arbitrary memory, used with extreme care. You can do various things, but you can't do them. Yeah. So basically you can do arithmetic as long as you keep the arithmetic within this like structure. And the reason is that if you keep a pointer and then you add to it somewhere else, like later in the program, the garbage collector might have run and like moved stuff around. And so then you get into trouble. But if you do it in a certain way, then like the Go runtime knows not to like mess with the GC stuff too much while this is going on. At least that's my understanding of how it works. You can do various stuff with it. You just have to be kind of careful. Yeah. So yeah, let's go ahead and add this. Well, let's see. I guess we have to say, let's actually make one commit with just the test. So add interval to batch. I guess we can say call crd, add interval serialization benchmark, release note none. And so we can just do this so that we can then compare before and after. Okay, so now what we can do is say script bench like this. Except instead of decimal, we're gonna do interval and see what we get. So just some small improvements. I think it's good though. You know, it's nice to sometimes go through and optimize some of this old stuff that you haven't touched in a while. Okay, so usually when this happens, it means that something went wrong. Normally it's supposed to spit out the results. So what went wrong exactly? Oh, it's because we didn't reorder. Crap. What did we do? Yeah, I think size of is about exactly. It's about the portability. What the heck did I just do here? I think I want to jump back to this spot here. Git reset hard. This thing. So now we're gonna do git rebase I origin master. Then we're gonna put the benchmark first. That's what we wanted to do. Okay, so now I think this should work, hopefully. So we'll try again. Okay, so what we see is a great improvement. Check it out. We see 71% reduction in time per op and 76% reduction in allocations. So very good result. Great job, everybody. We're crushing it. We're crushing it. So then, let's see. I think there's probably one more to go. Easy clap, exactly. You get it, Peak 911. You absolutely get it. All right, so for Booleans, I mean, we can absolutely do the same thing for Booleans too. Well, can we? Or is this something different? What is the deal with this guy? Bool builder? No, I feel like this one's actually probably fine. This one is probably fine. We're gonna leave this guy alone because it's pretty weird. Uses sort of a special case in the arrow library, so it's probably pretty quick. But timestamp TZ, on the other hand, is not so good. But this is the one, again, I don't think that we can really improve, unfortunately, because it doesn't, unfortunately, seem to let you do better. It's really too bad. It's really, really too bad. I guess conceivably we could just sort of vendor this code in a sense. We could just copy this code and make it more efficient. Maybe we should just do that. On the other hand, these things are private, so it's probably pretty tricky. Yeah, we probably just won't do this. We'll probably just leave this one alone. This is a little too bad. I wonder if there's some special case fast path where this doesn't have to allocate if it gets appended. No, I just don't think so. You see the problem, you guys? It's basically that, like, if you call Marshall binary on this time object, then what it does is it allocates a new array to give you back stuff. And this, of course, will kind of cause an allocation because it gets returned. I don't think there's any way to convince the Go compiler to avoid allocating for this. So really, ideally, what we would have is this Marshall binary thing. You could also pass in a byte slice, like an append. Well, I can't edit this, but I could pass in an append to in the argument to Marshall binary, and then it would, instead of returning a new byte slice, it would just write these bytes into the passed in byte slice, and that's going to be more efficient. But I just don't think there's anything we can really do about that, unfortunately. I guess the only exception would be if the Go compiler could know that if I did this pattern and I said append, you know, v is equal to append v marshaled, and it like noticed this pattern in particular, it wouldn't have to escape. I feel like there's a chance that that could be true. So I suppose I might as well just try it out. Let me move this up to the same type, the case that we were looking at before, and find out. So interval, decimal, float, and we got time. So we're just gonna kind of copy this same pattern, get our offsets, get our values. And I think in this case, it's going to be 0. I think there's probably a very specific size that we can do here. So bytes, 14 bytes. So 14 bytes. So timestamp size is equal to 14. C implementation of time.marshall binary. And we're going to make our values the size of n times timestamp size. And we're going to not append null. We're going to grab our offsets. Guess let's call this cur non-null index. So we're trying to prove to the compiler that some value won't escape to this scope and doesn't need to be heap allocated or GC'd. Yes, exactly correct. I don't think it's really going to be possible, to be honest, but that's okay. We'll just try it out and see what the compiler says about it. So we get our offsets, and then we're going to append, go like this. Basically same. I should probably refactor this stuff so I can not have to repeat all this code, but we could do that another time. Cur non-null index. Let me say cur non-null index plus plus down here. Okay, and then finally, we do our unsafe cast offsets array. Do I have a words per minute? I certainly have some words per minute. I don't know what it is. We could do it. You guys want to do a type racer? We could do that. I've seen some streamers do that. They'll like send a link to all their stream. See if anybody wants to compete in typing speed. So yeah. So we do this timestamp stuff. Let's see. Go ahead and check to see if this actually tests properly. First of all, unsupported version? It means I got something wrong. Oh, it's just because of this. Okay, we're using the wrong pattern here. We need to use... Okay, everything is completely wrong. We need to say offsets, we'll say values is equal to append values marshaled. Yes, it's a cast. It is a cast. So we don't need this cur non-null stuff. We just need len of values. This thing is len of values. Get rid of this stuff. Okay. I think that this is going to fix that problem. Okay, very cool, very cool. So we can actually go ahead and use the compiler itself to say whether this thing escapes to the heap or not. So why don't we go ahead and check that? We'll say, let's see, go tool. I think we can say go build dash m package call crd. Does this work? No. How does this work again? GC flags equals m. Okay, so then if I use less on, oops, I need to say 2 and 1. Okay, so this allows we can look at some compiler debug output here. And then if I look at for arrow batch converter, which I guess we already have, and we should look for line 205 or so. I don't think that it's going to be able to do anything for us here, because trouble is that this thing is like deep inside of some other library. So I just don't think it's going to be smart enough to know that it doesn't have to let this it doesn't have to let this escape to the heap. I just don't think it's really possible. It would be cool if there was some kind of assert that would create a compiler error when a variable escapes. Yeah, that's something that I've been I wrote this tool for that actually called GC assert. So GC assert lets you say, oh wait, no, I didn't add this yet to GC assert. So GC assert basically lets you add some assertions to various lines of code in your program to make sure that the compiler doesn't do various things. So it allows you to either assert that a function is inlined or bounds check eliminated. I don't yet have a way to have it assert that something doesn't escape to the heap. And that would be a great feature to add. So if somebody feels like hacking on GC assert, you should totally feel free to add a new directive like GC assert, no escape, something like that. But anyway, I don't think that we're gonna get lucky here, unfortunately. Well, wait a minute. What was the line again? 205? 205. So 205 is not found. What about 209? Yeah, I don't think we get anything. Bounds check elimination sounds nice. I want this in Rust. I'm sure bounds check elimination exists in Rust, no? Or are you just talking about the assertion? Do I have any life regrets? Not really. I'm pretty satisfied with life. What about you, Daffa Fadge? Is this like an elaborate troll? I feel like I'm being trolled right now for sure. Anyway, so I think if we can maybe run some benchmarks with timestamp TZ, see if there's a difference, that'd be cool. I don't think that there will be though. There's usually bounds check elimination, but usually look into the assembly to see if there's bounds checks. I see. You should be able to look at some kind of like compiler output, right? Like it's got to tell you, no? Okay, so let's go ahead and see using our script whether we get a difference here. I'm guessing that there will be no difference, but we'll find out. Timestamp. Release builds slice indexing doesn't do bounds checking at all. Wow. Yeah, wait, that doesn't make any sense at all. Like, what if you do a slice index with a random variable? Of course, it's gonna have to do a bounds check, right? Or unless it just lets it completely crash. Does Rust not let you just do an arbitrary lookup into a slice? It feels like it might be inaccurate. I don't know. Too many regrets not trolling. Well, Dafa, here's my advice to you. Live life as if you've got none of those regrets. Every day is a new day. So it's actually faster. I don't really know why, but I guess it's because we pre-size the array. So we'll keep this one as well. We'll keep this one as well, even though it's not as big as the other ones. I think it's just because we're pre-sizing that array. It doesn't let you unless you unsafely tell it to. Oh, okay, that's pretty cool. Rust, such a safe language. Amazing. All right. Well, we're doing good. We are doing very good here. We made some major improvements to the arrow batch serializer. Read some discussion about Go's very minimalist approach. Makes you reinvent the wheel a lot. Is that actually a thing? I think that's definitely a thing. That it comes up a lot. Like, for example, if you wanted to have, I don't know, like it's pretty hard to write generic higher order functions that are efficient. You just basically can't do it. So for example, if you wanted to search through a list, searching for a predicate, you would have to like write a little for loop, right? So for I equals 0, or for I in range, list, check if list of I is equal to whatever, right? And so that people complain like, oh, you have to reinvent the wheel a lot, like write these little loops. But I think overall, I've grown to be used to that kind of thing because the code is so straightforward that it's like, I mean, looking at the 5 lines of a for loop versus like the 1 line of a filter, I feel like I've grown to kind of prefer the for loop because it's just, I don't know, it's just sort of like in your face, straight line, nothing hidden. So I think that's kind of the philosophy of Go. There's like not as much hidden as there is in some other languages. It's like you really have to write out the straight line code of what you're trying to do. And I think in the end, like, yes, you do end up writing some more boilerplate in some cases. Like obviously there's the if error not equals to nil spam that gets everywhere. But like, again, at least it's explicit. I don't know. I think if you wanted to do a binary search, that's where things like get a little ugly, like a little bit of more of a generic algorithm you can't do. Yeah, you have to re-implement it and it's kind of gross, or use interfaces, which are kind of slow. So, but again, they're going to solve that with the generics thing. So yeah, I don't know. I guess I would say yes and no. Go doesn't have set in the standard library. Yeah, but you just use a map. I mean, I don't know. I was confused by that at first too, but like literally you just use a map and it's identical to using a set. So we're not really missing anything without sets here in Go. But there's better examples besides set for sure, like a binary tree, for example. Mo Kadumi, thank you for the follow. So yeah, I don't know, guys. Look, we did some good stuff. We definitely did some reasonable stuff here. Code should be readable. Shortening the search to make it look cool isn't worth it. Yeah, some people would argue that for sure. To me, Go's biggest win is the static binary. What's up, Remik? Some time ago, I asked for some database internals related books, and some reading and research later, it turned out that my BE thesis will be about databases. Don't have a specific topic, but I'm excited and I wanted to thank you for instilling my interest. You're very welcome. That's very nice. I appreciate you sending the note. Good luck with your thesis. That's very cool stuff. Very heartwarming. Thank you again for bringing such a nice message to this channel. But yeah, pop in like after it gets started. Come back and talk about what you're working on. I'm sure everybody would be interested to hear about it. It's cool stuff. Confusion with respect to Rust slice indexing. Oh, that is okay. Easy to say. Yeah, I don't know. I feel like I make mistakes when I'm talking like 20 times a day, so it's okay to make mistakes, write the wrong things. So yeah, I don't know. What else, guys? I feel like the other big thing, scared as hell because it's such a broad topic. Yeah, that's fair. It is a pretty broad topic, but have you picked a imposter syndrome is too real? My colleague wrote this really good thing about imposter syndrome. Imposter syndrome, Adam Storm. Check out this article. I feel like this is a pretty good article about imposter syndrome and how literally every engineer feels imposter syndrome, even no matter how senior. You know, I feel imposter syndrome. We all feel it. So it's, as long as you remember that, then just remember that everybody's feeling probably those same feelings, no matter where they are in their career. You know, they join a new company. It's like, oh my gosh, who are all these smart people? How could I possibly compete, right? So everyone's gonna feel that stuff. But yeah, I don't know. My message is that you can do it. Put your mind to anything, you can figure it out. And after you put your mind to it for a little while, the people are going to be looking at all of the stuff that you've learned and feeling like, oh my gosh, how did he or she learn all of those things? So yeah, it's an interesting field, the computer science and engineering. It's because like I think there's like less credentialism, I guess, in the field, and it's like, I don't know. Of course, like when let's say you're a young med student, something. I don't know anything about doctors, so if I say something totally wrong, you know, don't. Well, I don't know. Anyway, hopefully I won't say anything totally wrong. But you know, you're a young doctor. You're a first-year med student, and you go to your, I don't know, you're like doing a practicum or something. I don't know any of the words here. And you go to the hospital, and there's like the senior doctor, and they're like showing you stuff. And are you gonna feel imposter syndrome at that point? I don't think so. I think you're gonna feel like, wow, I've got so much to learn, and like one day I'm gonna become the senior doctor. I don't think you're gonna feel imposter syndrome, right? You know you're still a student. And so the question is, why is it in computer science and in engineering that when you're young, you look up to people who are senior, and you're like, oh my gosh, I'm an imposter. Like, how come you can't feel like, well, I'm still young and I have a lot to learn, and of course they know a lot more than me because they've been doing this stuff for 10, 15, 20 years. Anyway, but that all being said, like, it's totally real and everybody feels it. It's just like, it's kind of interesting how it manifests so strongly in engineering. I don't know why that is exactly. Worst case optimal join algorithms. Yeah, I have heard a little bit about that. It's something that I thought we might have started looking into at one point, but I just don't, yeah, I don't think we've like spent a lot of time on it just yet. CS has a ton of stories about prodigies who achieved X by age Y too, don't forget. Yeah, that's a good point. That's a very good point. That's a very good point. Like, yeah, so like Mark Zuckerberg or something was like, you know, he was age 18 and then he already had founded Facebook or something like that. That's a good point. I mean, part of the reason for that is like, yeah, I think it's like, that's like the mixed double-edged sword of it being so easy to get started with programming, right? It's like, there's a lot to learn, and a senior programmer can know a lot of things that they've been studying for 10 years, 15 years, 20 years. But in the end, like the things that they're doing, right, it's going to look very similar to the thing that the 1 year person is doing, right? It's like you write your for loop, you know, you write your web app or something. So there's kind of like a little bit of collapse there in terms of what you have access to. It's very democratized. Anybody can, you know, open a text editor and start writing a web app. So that's a good point. It is very different in many ways. You're absolutely right. 0 to hero stories. Yeah, anyway, all of you guys can do it though. You just put your mind to it. It's going to be hard, but you can do it. Don't have any imposter syndrome in CS because I'm doing it as a hobby and studying physics. Yeah. You solved the same coding problems and did whiteboard most of the time, but they appear to know more than you. WTF. Yeah, exactly. Yeah, it's tricky stuff. I mean, I guarantee you this, you guys. Like, you're gonna join your company, or if you're already at a company, ask your manager. Like, have you ever felt imposter syndrome, or like maybe you feel a little bit and you don't want to admit it, but or maybe you do admit it. You're like, oh man, I really feel imposter syndrome. They're not gonna be like, what's the deal? Like, what do you mean? We thought you were so smart and you're saying that you're not? No, that's never gonna be the answer. It's gonna be like, oh, of course you feel that. It's totally okay. It takes everybody a long time to onboard here. It's a lot of work. You're doing great. Nobody's gonna actually feel what you're afraid that they're feeling, right? You're afraid that they're thinking like, man, this person is just not up to speed. But really, what they're probably not really worried about that. Yeah, I don't know. So I guess my advice is be open about it. If you're feeling these feelings, don't feel like you have to close off and not talk to anybody about it. Say, man, I'm feeling really imposter syndrome, and people will coach you through it. They can ask you questions. They can point you at learning resources. They can empathize, they can give you all sorts of advice, and I guarantee that all those people that you're going to talk to have felt similar things before. Getting hired versus working is one are very different things. That's true. The hiring market can be really tough. That is absolutely true. Absolutely true. The world is a harsh place. Why do we have this special type business is another question. Can we just get rid of that? Well, I don't know if I'm going to do that right now. I feel like at this point, what I ought to do is what? Maybe we could just like benchmark some random TPCH queries. That could be fun. Okay, so you guys know about, whoops, dang it, I opened Microsoft Office tab again. Do you guys know about TPCH? TPCH is this really cool workload, very famous. It's a data set and it's got queries, and it's designed to help people kind of analyze the differences between databases that can run analytics queries. And so you can look at the queries here. There's like 21 of them, 22. And basically they all exercise different capabilities of the database. Oh my gosh, and there's also this really cool paper. I was just talking with people about this. It's called TPCH Analyzed, Hidden Messages, Learned from an Influential Benchmark. What an amazing sounding paper, right? So let's take a look at this again. TPCH Analyzed, Hidden Messages and Lessons Learned from an Influential Benchmark. Peter Bonks, Thomas Neumann, and Ori Erling. So what's so cool about this paper is that for every query, it's got a list of optimizations. And for every query, it's got a chart of how much a particular kind of optimization affects the query. And so it can be really neat to kind of play around with this and see what your database is doing. Is it using all of these the optimizations that this paper has thought of, right? Like, let's look at one example. Rewrite like into a range query. This is something that Cockroach does. So what does it mean? Queries 2, 9, 13, 14, 16, and 20 contain expensive like predicates, blah, blah, blah. and they've got a percent sign at the end. And in SQL, that means like, you know, let's show it off. Equal local 3, use tpch, show, let's see, show create line item. What is the right, so P type, is that the idea here? P is from part sup, I guess. Show create part sup. No, not part sup. I guess it's parts. Part. Okay, so check this out. Part key here. Now wait a minute. This is not quite right either. Where are my cool like queries? Where are my cool like queries at? Query 14. Query 14. Actually, I'm kind of confused about something here, which is that this p-type thing doesn't seem to be indexed. So I don't quite understand what they're talking about. Anyway, whatever. Let's go ahead and run and explain on this thing just to see what the deal is here. Explain. I picked a bad example. Okay, I'm going back to the paper. I picked a bad example. Let's ignore this completely. Hammer DB occasionally, normal SQL shell and not SQL command. I don't know what that is, but if the title of your paper fits in one line, have you really written a paper? Let's pick a better example. Let us pick a better example here. What about common sub-expression elimination? I feel like that's something that we do, right? A basic technique helpful in multiple tpch queries is common sub-expression elimination. In query 1, this reduces the 6 arithmetic operations to be calculated to just 4. Do we even do that? I don't know. So let's take a look at query 1. Query 1 is a big ol' query. Query 1 is a big old query, and it takes about 5 seconds to run on this machine, and it does some aggregations basically. And I guess the idea is that since there are some things that get reused, like 1 minus L discount, do we properly only calculate this once? Let's find out. Let us find out. Looks like we may not actually do this, you guys. How about that? Look, we see 1 minus L discount showing up so many times. I wonder if I say opt verbose, does it do anything smarter for us here? It kind of feels like we're missing some common sub-expression elimination. Does Cockroach parallelize queries across multiple cores? Are there mechanisms to stop one query from starving the whole cluster's resources? Yeah, so Cockroach paralyzes queries across machines more than like many cores on a single machine. It all comes back down to like, why don't we take a look at the explain SQL plan for this as an example? So, okay, this is very ugly. Very ugly. So here's the gateway node. Here's where we ask for the query to start. And it looks like what we do is we do a sort and we do some aggregations and we also ask some other machines to do work, right? And as we went through some of this earlier on the stream, but the main thing that we do parallelism wise is that we try to find where the leaseholder of a particular part of a table is located. So you can see that here we have to get, for the line item table, all of the data between 0 and whatever this is, line item number 1,792,417. And so since there's computation that has to occur on these line items, like a filter and an aggregation, we push these filters and aggregations down to the node that is the leaseholder. So in this case, node number 1. And then in node number 2, it's the same idea, right? The data in between these two spans, we push it down into node 2. So that's some parallelism. And then furthermore, in certain circumstances, we do have some parallelism on a single node, mostly when it comes down to flows that have like a lot of network hops in between each other. When there's lots of inboxes, each inbox kind of gets its own go routine, and stuff like that. But we don't do a huge amount of same machine parallelism. It's not really something that we've started playing with in Cockroach. I think it's something that we would maybe look at if people really want more analytics performance, but it's just not something that people have really screamed for so far. And yeah, so in terms of like, how do we stop things from overwhelming the cluster's resources? We have this big project to add admission control to the database this time around. And so that's pretty exciting. And that's going to be a way to make sure that if the database needs to really back pressure because it's out of resources for whatever reason, we can actually manage to do that. Right now, there isn't really a way to do that. It's kind of, things just get slower until they don't work. And nobody likes that. You want sort of low and consistent latencies or to get rejected. You don't want like the latencies to creep up and then nothing works. You want everything to be about the same performance. And then at a certain point, your query gets dropped if you're entering overload or queued. But anyway, yeah, that's kind of the idea there. Anyway, the point is this paper is really cool, and we probably don't even implement most of these optimizations, but we should be doing that. But let's go ahead and why don't we run this in profile, see what happens, see what the database is up to. Oops, I screwed up. Let's try again. Let's run a longer profile. 5 seconds is not, well, maybe it's fine. We'll just do 5 seconds. Oh my gosh, it got really fast. I guess it's because it got loaded into cache. 1.4 seconds. That's actually super fast. Anyway. So, oh man. Someday, still watch row level security, leaking data between tenants and the application is their biggest fear. Yeah, it's on our list. It's not, unfortunately, on our now list, but it's definitely on the list.
The data bank's too big.
Thanks for the follows, Alo Lejos, Snow Foundry, Nabil. Yeah, I mean, what's kind of so crazy about the vectorized stuff is that it's just so darn efficient. Like we're doing all of this work and it doesn't take any time out of the flame graph. All of the work is done by this thing, process value bytes, which is doing the actual decoding and the copying. And I always wish that we could be doing better, but it's just so hard to do better at this point with this stuff. Sorry for bumping the mic there. But like, check it out. It's kind of crazy, right? Like the whole query, I mean, it spends like 90% of its time doing this decoding stuff. It's just so sad. Like the actual computation is so incredibly cheap compared to the decoding that it's almost like a non-thing. It feels wrong, or it doesn't feel right. Like it either feels wrong because the decoding's too expensive, or it feels right because we've optimized the crap out of the actual computation because of vectorized. I'm not sure, it's one of the two. Why is this spinning forever? I'm confused. I love staring at this process values bytes thing because I've stared at it for so long, and I always think that there's nothing more we could do, but maybe there's more we can do. I don't know. I kind of doubt it. At a certain point, it's like, why isn't this thing not loading? I'm confused. Let's see. View, source. Why does that not work exactly? Well, I suppose we could just take a profile from the command line. Let's do that. So we're gonna say pprof. I guess we have to say go tool pprof https localhost 80, or is it 8080? No, it's 26 258 debug pprof seconds equals 10. Debug profile. Okay, I forget how to do this. Let's see. What is the right URL again? It's like debug pprof UI. No? Debug pprof. Debug pprof UI profile. There we go. Okay. Now we run this a couple times. Okay, so yeah, look at this. All the time is spent in process value bytes. Why? It's so sad. Wait, what? How come it doesn't have source information? That's unfortunate. Oh, there we go. Okay, so there was just some problem with it. But anyway, check this out. Like this is where all the time's spent, I guess. And it's little bits here and there. It's not great. So I mean, the thing with this cfetcher is it's this really complicated state machine that we made to try to like avoid doing as much work as possible when decoding this data, because it's so confusing how to decode this data. There's all this information, like which columns do you need, what the types are, what the families are, do you need to continue, like there's all sorts of weird stuff. You skip, there's crazy amounts of state. And so we made this state machine that sort of allows you to skip as much work as possible. But part of me wonders whether like all of that extra logic to keep track of what you can skip and what you don't have to makes things worse. It's like definitely possible. It's almost like what you really want to do is make some sort of, instead of having all these ifs, maybe what you do is you do like a little, like a actual state machine, you know, like a thing with a lot more fine-grained states, and you send sort of like a program written in these instructions to the state machine instead of all these ifs. I don't really know though. Yeah, it's like I just think it's like really expensive. All of these conditionals probably really add up. Because if you think about it, like the rest of the code that we do, all of that like computation code that we do, like what is this query doing again? It's basically like just you know, I mean it's just like there's no ifs in here, right? You're doing some sums, you're adding, you're subtracting. And you know, like what the heck kind of crazy stuff. Okay, so it's like you do your scan, you do a less than, you do a minus, you do a mult, minus, mult, plus, mult. hash aggregator, cast, divide, cast, project, you know what I mean? It's like all these things that you just don't need to ask any questions to do them. So it's super fast. And so I guess the question is like, maybe since that stuff is just so efficient, all of these ifs just like are kind of terrible and there's nothing we can really do about it. I don't know. Maybe this one's not really so fruitful to stare at in the profiler. Oh yeah, the other super crazy thing about this query is that it ends up actually spilling to disk for no reason. We were talking about this. So I think if I say set work mem is equal to 1 gigabyte. No, set, what is this work mem stuff? SQL dis-SQL temp storage work mem. Set cluster setting SQL.dis-SQL. Temp storage dot work mem is equal to 1 gigabyte. Then I run it again. It's no faster, really. So if I think if I take yet another profile, it'll probably remove like a whole chunk of that, and it'll probably be even more in that decoding routine. No, it still does some stuff in this. It's kind of weird. Sometimes I wonder if compiled languages could benefit more from JIT optimizing functions away. Yeah, maybe. I think in this case, the JIT stuff would have a really hard time because we've already like done the major, like all of these chunks here. This is like what the JIT would do good at, and the part that the JIT would do bad at is this stuff down here. I think to make this stuff really efficient, we would have to rewrite it again to be different, using a state machine instead of the kind of map structure that we use right now to encode the different states and what you have to do. I think if we rewrote this thing to be like a real machine, give it these like really low level instructions, like, in a loop, decode a integer, decode a byte, decode an integer, decode a byte. So it wouldn't have to check. That would make it really fly, but that's a lot of work. It's a lot of work. Like the thing that would actually make this really good, now that I'm thinking about it, is if we go process value, like, where is this thing? Decode table value to call, like this thing, right? Well, this thing does take a type. I guess the point is that like at this point in the code, we actually know, I think we know statically what the value type is, right? So the way that we make this work right now is we jump to the IDX column of this thing and we call get type on it, and then we've got the type. But the truth is that like based on the fact that these columns stay static for the whole lifetime of this C fetcher, we actually really should know at this point exactly what the type is. We can skip having to jump into this, and we can skip having to do this big type switch. We can actually jump, you should be able to jump directly to, whatever it is, like this guy or something. And that would make it really fast. And that's what I'm talking about with these like instructions. We should be able to have like a little virtual machine that's doing these instruction processing, and that would really make it fast. But just is a lot of work. I don't know how to structure that really. It would be really difficult, but pretty cool. I'm sure that, I think a lot of other databases work like this more. Like they have these little virtual machines and you send them instructions and they kind of follow them. But ours doesn't really do it that way. Anyway, let's go ahead and clean up the commit that we made and submit it. And then I think that might be our stream. So let's see here. Let's edit this commit here. Whoops, I didn't mean to do that. We'll say git commit amend. This is gonna say
Computers hooked into over 1,000 data banks throughout the world.
call crd optimize encoding. Optimize arrow encoding for some types. Previously, the arrow batch encoder no, I don't live in ATX. Does that mean Atlanta? I don't know what ATX is, but I live in New York. That'd be pretty funny if you saw me though, Nulls TV. So previously the arrow batch encoder used an inefficient method to encode the following data types: decimal, interval, timestamp. What else? Was it just those four? I guess other data types that are not supported by vectorized without built-in support in vectorized. This commit improves the performance significantly for these types by avoiding extra allocations and copies for each of the for scratch buffers for each of the elements in a column. This will provide marginally increased performance, especially for distributed, I guess we'll say for distributed queries that need to send a lot of data of these data types across the network. Release note: performance improvement. Improve the serialization performance. I guess it's sort of like improve the performance for distributed queries that need to ship around decimals, intervals, need to send cross network. How do I say this? Improve the performance for need to send a lot of data of certain data types across the network. I don't know. So let's include these benchmarks here. You know what I ought to really do is I should probably rerun all of these benchmarks just on the ones that I care about or something like that. So we'll do timestamp, interval, and decimal. Can I do like this? Timestamp, interval, does this work? It's definitely not working. What if I put some single quotes here? Maybe sprinkle some escape characters. Will that help? Definitely not. What if I get rid of the escape characters, but keep the single quotes? Okay, I think this is working. Okay, so we're gonna do this again, but we're gonna use the scripts bench. Okay, we're gonna use the scripts bench, and we're gonna say we want interval, timestamp, or decimal. Okay, and the purpose of this is just to clean up the output so it's possible for people actually to interpret it, see all the 3 data types besides each other, just make it a little bit easier to see the benchmark results. Not a huge deal, to be honest, but that is okay. So we'll let these benchmarks run, and till then we can just contemplate the universe, you know? CockroachDB licensed. It's all open source Sora, so it's source available. That's definitely true. And there's some parts of the source available code that are licensed differently than others. Some is licensed. We use this thing called the BSL, which you might have heard of in context of things like Elastic. It's basically a license that says, you're free to use this for yourself, but you can't use it to create a hosted platform that provides CockroachDB clusters for somebody. So it's sort of like an anti-AWS clause is kind of the idea. So prevent people from making money by hosting your database for you and charging for it. But it's all source available, so you can you can go to GitHub and see all the source code there. Besides Go, what other languages do you work in and enjoy? I like Python. I like Lisp. I like Clojure. Like playing with, I don't know if you've heard of this language called Factor. I played around with Factor a bunch, which was pretty fun. I don't know. I liked. Do I like Java? There's some good things. I wouldn't say that I love Java. I kind of like Java. It's fine. Played with Scala. Played a little bit with Rust. Rust seems cool. I haven't played enough with Rust to know whether I like it or not, but it seems great. Everybody seems to like it. So, yeah, I don't know. Those are some things. Yeah, Clojure. Clojure is awesome. I'm a big fan of Clojure. I wish there was a Clojure that wasn't so JVM-y, but actually part of the power of Clojure is the JVM, right? So maybe I don't wish that. First language was PHP. My first language was this thing called HyperScript, which is this language that came with this program called HyperCard, which was this Mac program that let you sort of make these multimedia things and link them together and make buttons and games and stuff like that. That was actually my first programming language. Either that or QBasic. One of the maybe technically I played with QBasic before HyperScript, but I didn't do that much with it. I sort of just entered programs that other people had written and played with them, like gorilla.bass. I don't know if you guys remember that, but yeah. So wrote Java exactly once. Visual Basic, Java at work and Go at home. Delphi 1, then Java 5. These are some good ones. What else? First intro to programming was making AOL programs to kick people off AOL in the 90s. Yeah, I did some stuff similar to that for sure. I guess for me, it was more like IRC scripts and stuff like this. These days I fix C++ and write Rust. JavaScript is the devil. All right, so here are my latest benchmark results. It's a little bit cleaner. So we'll do git commit amend. feel like something confusing happened with the formatting here, but right? What's the deal with this formatting? It's supposed to all be on one line. So let's fix that. First language was JavaScript. Nice as a first language because it goes uphill from there. That's funny. Oh man, it got all unaligned. This is so sad. Why is it doing this? I feel like there's some... Honestly, I feel like there's some problem with the Windows terminal that I'm using. Oh, you know what it probably doesn't do is it probably doesn't like preserve tab stops or something. Okay, I'm just gonna manually align it. This is fun, right guys? Manual alignment of stuff. Have you ever seen something sadder than this? This might be the pits. This might be truly the last straw. Use Vim shortcuts for cursor navigation and you have cursor keys on a layer. I use Vim shortcuts, but I also have cursor keys on a layer. So how about that for a non-answer? I do both. So here's this is my cursor keys on a layer, and here's my Vim navigation. You could do both. Yeah, the layout is published online. It's I always forget if I have like a command for this, like a QMK or something. No, hold on. Let me this is like a commonly asked thing, so let me get that. EBO maybe? Iris. Key maps. So we're gonna do a commands add QMK. Here's my Iris QMK layout. All right. So back to fixing this up. Oh crap, I forgot to align this front part. So it's gonna screw everything else up. You get to see how bad I am at text editing here. It's exciting. This is like the Vim gym right here. That'd be kind of funny, the Vim gym. I sort of like that. Okay, so that is all that we're going to be doing on this thing. Okay. So let's go ahead and make a PR for this. Yeah, so we're going to take mainly this commit here. Like the other one, we'll obviously take it, but we don't really need its commit message since it's just to add that benchmark for reasons. All right, so this is seeming basically pretty good. So let's go ahead and send it. So not too big of a PR, but it's pretty impactful, I would say, right? 200% improvement on this one. I'm into it. We did good. Yeah. I feel like that's that. I think we're gonna go ahead and find someone to raid. Let's go ahead and find someone to raid. Been a bit over 5 hours. Good time to take a pause, see who's on this science and technology world here. Let's see here. Who's on first? We got Griffing. He's doing Doppelstraw. Try Hack Me Tribute Room. What is that?
I guess we'll do this one. Join the room.
I don't know. I don't know about this like hacking stuff. It's not my jam. Ludum Dare warm up. Learn to code for free serverless. What about Java loves OCaml?
Eu 5JKS.
Oh, he's speaking in non-English, Spanish maybe. Well, I won't send you to a Spanish channel. It's cool that there's non-English language science and technology streams going on though. You too, Nami. Thanks for stopping by. Maybe we'll give Anthony a raid.
You
How
want
about
to get
that?
people that actually know how to code.
I feel like he's raided me recently, so let's give him a raid back. All right, so we're gonna the old he writes code. All right, so you guys know the drill, right? We're gonna send some emotes. Okay, so here's what you have to do. All right, listen to me right now. We're gonna join the channel and we're gonna spam emotes. It doesn't matter what they are. Here's some suggested ones. Here's some suggested ones like this. All right. Let's go ahead and paste it. So do me a favor. You viewer, copy and paste those emotes right now into your buffer. Okay. And when we join the channel, I want you to paste them into the chat so that Anthony knows that we have a high viewership. You know, we have to show the power of large data bank to Anthony. All right. You guys ready? Let's do it. Have a great weekend. Thanks everybody for hanging out. It's been so fun as usual. Probably I will see you next week on next Friday. Maybe we'll do a Sunday stream. Not sure. But if not, see you guys next Friday. Have a good day. Bye.